coders, welcome to this new course on C++ programming. My name is Prashant Chaudhary. I welcome you all to this course. Many of you have requested to create a video on C++ programming. So here it is. So let us begin. We'll start with the basics first. So C++ is a middle level language. It was developed by John Strostrup starting in 1979 at Bell Labs. C++ runs on Windows, Mac OS, and different Unix distributions. So it doesn't matter which operating system you're using, you will obviously find a suitable compiler. GCC is one of the most common compiler. Few colleges are using Turbo C compiler by Boland. That is also fine. There could be slight differences between the programs, but that is still okay. Most important thing is you to understand the concepts. So who can learn this course? Anyone. Anyone can learn this course. And when we are learning this, knowledge of C languages is not needed, but it is good to have because I won't be explaining programming logic or how the programs are executed in this course. So all the students, professionals can take use of this course, and what to expect from this course and what not. You will not learn this language in a day, so have patience to learn. It could take some time. While saying that, I can assure you that learning C++ is not hard, but it needs time and practice. So it will build foundation of object-oriented programming concepts. And if you want to learn programming logic, you can do that separately by watching our video on C programming, where we have covered 101 programs. I'll be giving link to that video in the description box. Also, I'll add it in the eye icon at the top. So when you're learning C++, which compilers to use? On Mac OS operating system, you can use either Xcode or GCC from terminal. JN use GCC compiler, and on Windows, you can either use CodeBlocks or Turbo C++ compiler from Boland. In case you are finding trouble in setting up the compilers, then you can use online resources. I can suggest you two websites. One is ide1.com and other one is onlinegtp.com. So these websites have online editor. You can write your programs over there, and you can select the compiler and click on the run button. It's fairly easy to use, so you can give it a try. So what are we going to cover? So basics like data types, constant variables, we are just going to touch those at the very basic level. If else, while loop, for loops, function pointers, strings, and arrays. So this is something that we have already covered in the previous video. We have created a video wherein only theory is there. So I'll explain you about that in a bit. But majorly what we are going to cover in this video is object-oriented programming. So we'll be concentrating our study on classes, objects, inheritance, overloading, polymorphism, abstraction, encapsulation, and interfaces. So here is your first C++ program. So hash include iostream is the header file that we required on our C++ programs. Again, using namespace std. It could be optional on Turbo C compiler. So these files are required basically to perform input-output operations and execution of your program. These double slash lines are nothing but a comment. Similarly, this line is a comment. As we all know, semicolon is something that separates all the instructions. So these are two semicolons. So this is my main function. It has two instructions in it. Notice that main being a function, it has a return type int. So at the end of the function, I have returned 0, which is an integer. So this statement, cout less than in the double quotes, I've written www.kodegod.com. What this statement does is it will print www.kodegod.com on the output screen. So cout is used to print output on the output screen. So we'll be talking about this operator in great detail when we learn about operator overloading in the subsequent slides. The code lines can be like printing and returning values. Similarly, there could be arithmetic instructions like this, wherein I have given two examples: a equal to b plus 10, semicolon. On the next line, c equal to a minus 10, semicolon. We usually write our instructions one below the other. However, for compiler, writing statements like this is also okay. For compiler, these are two different statements. So semicolon is something that is acting as a separator. So because of this semicolon, compiler will get to know that this instruction ends here and this is the second instruction. So let us touch more on how we can add comments in the C++. So this is one example and this is the second example. So double slash is used for single line comment, and slash star and star slash are used for adding multi-line comments. You can add single line comments after semicolons also, so this whole part will be neglected by the compiler. So we use comments for our understanding, how to make code more readable and more understandable. C++ has added few more new keywords in comparison to C language. So these are all the keywords that are supported in C++. So you can notice these are new keywords. So private, protected, and public, these are a few common keywords that will be using more frequently in C++. Other than that, you can check the char, else, if, or go to. These are a few common keywords which we have used in C language more often. Now let me talk more about data types. So there are two types. We have primitive like bool, char, int, float, double, void, and wchar underscore t, which is a void character. And you already know about all these primitive data types. Then we have something called as modifier. Signed, unsigned, short, and long. These are modifiers. So these modifiers we can attach with the primitive data types. So for example, we can have signed int, or you can have unsigned int. So these are the set of data types which are available in C++ in conjunction with the modifiers. So this is the modifier and this is our primitive data type. So in the second column we have the bit width required for the type. So for example, int will require 4 bytes, and because of the 4 bytes it can store number from this given range. So we don't need to memorize this table, but this is just to have a general understanding how much byte size a particular data type will require. For example, float will require 4 bytes and so on. We can also do the declaration using typedef keyword. So syntax for that is typedef keyword. Then you add your type and the name of that particular variable. So for example, I'm writing typedef int wheels. So what is happening over here is wheels become a custom data types of type int. So instead of writing int car wheels, I can now write wheels space car wheels, and then I can initialize car underscore wheels is equal to 4. I guess there's a small mistake here. I forgot an underscore over here. So after we write this statement, so int wheels var is almost similar to writing wheels underscore var. So technically these two statements are same because wheels is of type int because of this typedef statement. Then we have enumerated types. So syntax of declaring an enumerated data types is enum, then your enumeration name, then in the curly braces you write list of the enumerated names, and you can inline create variable list of the declared enumeration. So for example, I am creating one enumerated type as gender and I'm setting two values as female and male. Notice here when I don't initialize anything, so default values are zeros and 1. So it starts with 0. So enumerated value female is 0 and enumerated value of male is 1. So G1 is a variable of enumerated type gender. Alternately, I can create another variable like gender G2. Then we have G1 equal to Gmail. Then we have G1 equal to female. So I'm setting value female, which is 0 into variable g1. Similarly, I'm writing g2 equal to male, so I'm setting 1 as the value inside of g2. Another example, I am creating another enumerator type as fruits. So when I don't declare values for all the variables, compiler takes reference of one value 4. Hence, apple gets assigned value as 3 and orange gets value assigned as 5. Now let us talk about variables and scope of the variable. So we can declare variables with the data type name and then variable list. So this is exactly similar to what we have done in C programming language. So int ABC, so ABC becomes 3 integer variable. Then char C1 equal to inside of single quotes capital C. So ASCII value of capital C gets assigned to C1, or alternatively I can write C2 equal to 67. In that case also ASCII value is stored into character C2. Then I can have a float variable initialized to 3.142. Name of that variable is I, and then another variable area which I'm not initializing. Another variable is double D. So D is the variable of type double. Now let us talk about scope of variables. Consider this as a program. When I write int x equal to 10, so here x is outside of main function, so it becomes a global variable. So x becomes available across all the functions. Similarly, inside of main function, when I'm writing x equal to 20, notice I have initialized x here. So this x is local to the function main. However, this variable x is global to our program. So when I write cout x, so compiler will give preference to the local version first. So output of this program is 20. We already seen that we can use type modifiers. So signed, unsigned, long and short, these being my modifiers, I can use it like this, short int x. So x is signed short integer, and then short unsigned int y. Here y is an unsigned short integer. Now let us talk about storage classes in C++. So by default, auto is the type assigned to all the local variables. So when I write int x, so variable x has storage class as auto. And then we have register as storage class. So whenever we require some variables which need faster access, so in that case I can use a register as storage class in front of data type name. For example, register int x equal to 10. So this variable x will be allocated memory inside of a register instead of RAM. Then we have static. So static exists during lifetime of the program, maintains value across all the functions. So whenever you define a variable of storage class type static, so that variable will maintain its value throughout the program and across all the functions. Then we have extern. There could be a case wherein your program is not a single file but it is spread across multiple files. So in that case you can use extern variable, and that extern variable can be referred from any other file. And the final type is mutable. It allows member of an object to override const member function. So this is something that this is something that I can explain later when we talk about const member function. Here is the example. Int x and auto int x is almost the same statement because auto is the default storage class. And here's the other example, register int index. So index variable will get allocated memory inside of register memory instead of RAM, because we have specified that storage class for this index variable is register. We'll take two examples on static and extern. As we discussed earlier, static exists during lifetime of the program and maintains its value across function calls. So in the example, I have static int I equal to 3. Then I have forward definition Then I have this function called as my function. So it is just printing value of I and incrementing it. And then inside of main function, I am just reprinting the value and incrementing it. Then I'm making a call to my function, and one more time I'm going to print value of I and increment it. So let us see what is going to happen in the execution. So very initially what is going to happen, compiler is going to declare a variable I and allocate it memory into RAM and initialize it with the value 3. So I is initialized to 3. Here 3 will be printed and then value will be incremented to 4. So these are the slash slash. I'm just writing it as a comment. Then we are making a call to function my function. So because it is a static variable, the current value, that is 4, it will be printed over here and value will be incremented to 5 because of this statement. Then compiler will move back to this position because execution of this statement is completed, and we are just printing value of I again, so which is 5, and value of I will be incremented to 6, and then your program will end. So you've seen here that value of I is maintained across all the functions. So in few scenarios it makes sense to use static variable, but not always. Then we have storage class called as extern. It makes variables accessible across program files. So in this example, we have these two C++ files, storage underscore classes dot CPP and extern.cpp. So in the first file, I have declared a variable. This is a forward declaration of my function print underscore extend. And then in the main function, I'm just initializing value of I to 10 and I'm calling the function print underscore extend. So this print underscore extend function is declared in this other file. So writing this statement extend int I, I'm referring to this variable and I'm declaring my function over here print underscore extend. I'm just printing current value of I. So output of this program is nothing but 10. So extend variables are used where you initialize few variables outside of main function and you require those functions to be used in some other files as well. So here is the command on in case you're using Mac OS and you're using GCC compiler, then you can use this command. You can write G++, your C++ file name and the second file name, because this program consists of two C++ files, and using -o, I'm telling compiler to create my output file as extern. In case there are no errors in the program, it will create executable file as extern, and then you can execute your program using this command. This is how you can use extend keyword. Now before I end this video, I want to reiterate that a few concepts like operators, decision making, where we have if else, nested if else, switch, and then we have loops, while, do while, and for loop. Apart from that, we also have function array, strings, pointers, file input output, structures, pointers. So these all concepts we have covered in C programming video. So what I have done now, I have created a separate video wherein only theory is explained again. What you can do is you can watch that video. Complete explanations and theory about these topics you can find in the I icon here. So before we jump onto the other parts of C++, I strongly suggest you to go through this video, just revise your theory one more time, so it would be quite helpful. So we're going to compare procedure-oriented and object-oriented languages first. So procedure-oriented languages work more like a function, or they work on a task. So we can say that these languages are more function or task-oriented. And most functions share common or global data with each other, or data is passed as parameters. So global data is passed as parameters. So these are only two possibilities in procedure-oriented languages like Pascal or in fact C. So let us look at this diagram over here. So in case of procedure-oriented languages, we have this global data in each of the file or across multiple files. So let us say these are individual modules, and all these modules have global data, and this global data is accessible via functions which are present in those files. Similarly, the same data can be accessible via other functions in other files. So again, not necessary these are different files. So this can be a single file or multiple files as well. So important point that I'm trying to make over here is that global variable is accessible across all the functions. All these functions can access this data, or this data. So in a way, there is no security. So any function is accessing anything. So now let us look at what object-oriented languages are offering us. So in case of object-oriented languages, data and functions are grouped together, okay, in these form of structures. So let's say this is one structure, this is another structure. Okay, let me call it as groups, because structure is something that we have already used in C. So let us not get confused with that term. So we are saying over here that functions and data are grouped together. So data is accessible from the functions of the same group. Okay, so outside functions cannot directly access the data. So this is not possible. So these functions or this group can access this data only if these functions are allowing it to do so. So this function can request or call these functions. These functions can internally communicate with the data and then send output or a response to these functions. Okay, so these functions can process local information and give output to the other functions if these functions are called. So similarly, this data is not accessible directly by these functions. Okay, so as we've seen, data becomes more secure in case of object-oriented programming. So data and functions are combined and data is hidden from external functions. And another important point is that more data and functions can be added. So like this is my model 1, this is my model 2. Subsequently, n number of models can be added. So moving on the next topic, that is what are the basic concepts of object-oriented programming. So these are very important features or concepts of object-oriented programming, like objects, classes, data abstraction, encapsulation. Inheritance is one of the most important concept or feature provided by object-oriented programming. Data hiding, again, as we discussed, and message passing. So these all important features we are going to discuss one by one. So let us start with objects first. So objects are basic runtime entities like student, course, or an animal. So these are usually real world objects, and they are generally used to define data. And these objects interact with each other to send messages. For example, object students can be used to interact with object course to process or use data. And while doing that, we do not need to know each other's data. So in case I have object 1 and object 2, so they both do not need to know each other's data. Now, important question is how these objects are created. So objects are created using classes, which is the next important feature provided by object-oriented programming. So we discussed that classes are user-defined data types and objects are created using classes. So in a way, objects are variables of type class. So like we write int x. So x is a variable of type integer. So when I have a class called as car, then Jaguar becomes an object of type class having name car. And when we create a class, we can create any number of objects of that class. So classes is a collection of similar data types. When I say car Jaguar or car Maruti, so Maruti and Jaguar are objects or similar objects of class car. So another example is let's say fruit is a class, and then apple is object of class fruit. So similarly, we can have fruit as class and then we have, let's say, apple, then banana, or let's say mango. So all these three are objects, and fruit is a class. Another important feature is data abstraction and encapsulation. So encapsulation is nothing but combining of data and functions into a single unit. So as we discussed earlier, data and functions can be combined together, which forms a single unit, which is called as a class. So this feature is known as encapsulation. So binding of data and functions together, or combining of data and functions together, is called as encapsulation. Next point is encapsulated data is not accessible to the outside world but can be accessed via functions. So when I have a single unit class, so data 1, data 2, so these are two data variables of that class. Then I have function 1, function 2, these two functions. So this in total is forming a single unit. We are calling it as class, and this data is not accessible to the outside world. It can be only accessed via these functions. So in a way, these functions works like an interface. So in order to access the data, you have to use this interface, and this separation also provides this security, and hence the term is known as data hiding, because we are hiding this data from outside world. So next feature is abstraction, and abstraction is nothing but representing essential features without too much background details. For example, if I have a class, so let us say I have a group called as car, then I will just have attributes or features of that car as, let's say, number of wheels, then type of car, okay, and so on. So I'll be using only essential features. I'll not be adding too much of the background details. I can create my own classes or these custom data types without too much of background details. So classes use abstraction, hence classes are also known as abstract data types, or ADT in short form. Now, one of the most important topic is inheritance. Inheritance allows objects in your program to extend or acquire properties of objects of another class. So let us try to understand this via an example. Let us assume I have a class vehicle, and then I have data members as speed and mileage. So this is my base class, and I'm going to create one more class wherein I'm inheriting or acquiring information from this base class, which is mileage and speed, plus I'm adding my additional information, okay, and I'm calling it as two-wheeler. Similarly, I have four-wheeler as a class name, and I'm again inheriting information from the class vehicle, and this is inherited information, speed and mileage, plus I'm adding seats or number of seats as additional data member in the class four-wheeler. Okay, similarly these can be further inherited too. Okay, so this is our example. So vehicle is the base class, and we have inherited properties from that class to class two-wheeler, similarly three-wheeler, four-wheeler, and so on. So the concept here is to reuse and add if required. Because we are reusing the code, it will save our job on creating the same variables again and again. It will save a lot of memory as well. It will save a lot of development time as well. Most important thing about inheritance is that we cannot modify existing features, as in we cannot modify properties of my base class. So I cannot go on and modify this variable name or delete these data members. Now next is polymorphism. Polymorphism is ability to take more than one form, or it gives multiple meanings to the same thing. So two important features in C++ are, or in object oriented programming, are operator overloading and function overloading. So same operator can do two or more different operations. That is operator overloading. So here let's say plus sign can either perform addition, or plus sign can be used to concatenate two strings. Similarly, in function overloading, we can use function add to add two integers, or it can be used to add two floats. So in function overloading, single function can return different output based on type of parameters which are passed to that function. So very important topic. We are going to touch these topics again in the next few slides. Next important point is dynamic binding. It is also known as late binding. A dynamic binding is nothing but linking of procedure call to the code to be executed in response to the call. So complex statement, let me try to simplify it here. Suppose we have class XYZ, and it has a function associated with it as function 1. So when we create this object at the runtime, when this function is called along with the object name, so at the runtime, so associated call or the definition of this function will be called. So in a way, this becomes a dynamic binding. So this binding is done at the runtime. Now you may claim that the XYZ is already created object, but you can at the runtime you can create n number of objects, right? So let's say you create multiple copies, n1, n2, n3, and so on. So all these technically can still call this function. Because these objects are created at runtime, binding is also done at the runtime dynamically. Another important thing is that code associated with the given procedure is not known until it's called at the runtime. The reason is also that associated functions are sometimes polymorphic or inherited. Again, to simplify, when we say polymorphic, that is either we have function overloading or operator overloading. So at the time of execution, compiler will make a call. That call is referred to which function. Similarly, function can be inherited, hence so those calls can be decided at the runtime by the compiler. And because objects will be created at the runtime, even in the case of polymorphic or inherited functions, there would be a dynamic binding. Now, the last important topic is message passing. In object-oriented programming, objects communicate with each other by sending or receiving information using parameters. So let's say student is my object, then display marks is a function, and then a roll number is a parameter. So this parameter is sent from the called function and is received at the called function. So if this code is inside of your main function or any other function, so this function is sending this parameter, and this function will be receiving this variable. So this is how message passing plays critical role in object-oriented programming. Now let us look at benefits of object-oriented programming. Because of the features that we have seen earlier, code redundancy gets avoided very nicely. There's very less redundancy in the code. Because of code standardization, development time is saved, and hence development becomes more productive. Because of feature of data hiding, object-oriented programming provides good amount of security. Models of code are easy to create, upgrade, and maintain in object-oriented programming. We have seen message passing makes communication very simple. Because of the overall features that we have seen so far, we can say that it reduces software complexity because of features like inheritance, where we reuse the code, or feature of polymorphism, where we can have multiple meanings of a same function. Now, before we begin with actual objects and classes, let us spend some time on how input and output can be carried out in C++. So we have two operators to do this job. One is a right shift operator. In case of inputting, we refer the same operator as extraction operator, and then we have insertion operator, which is left shift operator. So here is one example. I say int a semicolon, then cin extraction operator A. So whatever value that I'm going to enter will be stored in the variable A. Then I have C out. I'll be using my insertion operator over here. So C out insertion operator, my string enter number is equal to, then again one insertion operator, and I'm providing value of A. So whatever value of A that is entered at this table, let's say 10. So output of my this statement would be entered number is equal to 10. And we know that slash n is a white space character which will take cursor to the next line. From this line it will come to this line. So cin and cout is something that we will be using commonly. It is almost a replacement to our printf and scanf statement. Now let us touch back the topic of polymorphism. As we have seen, polymorphism gives different meaning to the same operation depending on the context. Okay, for example, we know this operator which is multiplication operator. However, in C language also we use it as multiplication plus we have used for pointers too. So in a way, C language also had this polymorphism feature. Now, in case of input-output operator, we know that this is a left shift operator, which was a bitwise operator in C. It is still a bitwise operator in C++, but depending on the context, when I use C out, it works as insertion operator. Similarly, this is our right shift operator in C and C++. However, when we use it in conjunction with cin, it works as extraction operator. So simple enough. Finally, we'll just check what is the structure of a C++ program. So here we have a C++ file. Then we usually start with header files, and then we have our one or more class declarations. Then we can have multiple functions, that is one or more function definitions, and after that finally we have our main function. So this is a typical structure of a C++ program. In upcoming lectures, obviously we're going to see many examples of C++ programs. So a class consists of data and functions. So clubbed together they are called as data members. So when I say the data is nothing but the variables which we declared in the class, and functions is something that are part of this class and can be used to perform certain actions, and the functions can internally use the data that is a variable of the class. So as an example, if I say human is a class, then legs and hands can be my data, and walking and running can be functions. So while walking and running, I can use legs. Similarly, another function can be eating, and I could be using my hands while eating. So class in a certain way is an entity. Now let us look at syntax of declaring a class. So class is an keyword, and a class name is followed by that. So I can write class XYZ, then a starting curly braces denotes that my class definition begins from this point, and these are my data members till this ending curly braces. Then inside class definition we have access specifiers. So I'll talk about it in the upcoming slides. So after specifying the access specifier, we have our list of variables. Here I'm calling them as data members. So data members are declared using your standard data type and variable name pairs, and you can have one or more data members like this. And then you have your set of functions. So a typical function declaration can be of this type. So we have return type, it could be integer, float, and so on. Then you have your function name, and then in the parentheses you have your list of variables. At the end of your class definition you have list of objects. So there are two ways you can create objects of a class. that is immediately writing it after the class declaration like we do in the case of structures. And another way could be using your class name and then your object names. So we'll talk about objects in more details in the next slides. So for now, just understand you can create objects at the end of your class name like this, just adding them just before semicolon, or you can write it anywhere in the program using class name and then object name list. Now let us talk about access specifiers. So in C++, there are three access specifiers: private, public, and protected. So private is the default one, as in when you don't write any access specifier, private is considered by default. When you specify access specifier as private, in that case, all the members which are part of your private access specifier scope, then all those members can only be accessed within the class, as in those cannot be directly called from outside of the class. On the other hand, when you have access specifier specified as public, then those public members can be accessed from outside of the class. And finally, there is third type protected. This is something that is used in inheritance. So let us not get into that at the moment. Let us try to first understand how access specifier work with the help of this class diagram. So this is my class and I am having there two access specifier. One is private and other one is public. So if you just closely look here, what we have done is these public members are separated with private members. Okay, so these public members, however, are accessible from outside the class. Okay, and private members are not accessible. If you just take over, there's no access. However, you can access these private members using your public members. Okay, so public functions have access to private data and private functions. So public functions can not only access public data, but they can also access private data. I think it's pretty clear now how private and public members are accessed. Now let us try to understand how access specifiers can be declared using these few examples. So let us say I have a class name as my class. So if you just notice here, I have not written any access specifier for this first variable int data1. So by default, this becomes a private access specifier. So this becomes private data member. And then because I have written public as the access specifier, so all these members become public members of the class. So there's another example where I have explicitly written private. So technically both these examples are similar. Only thing is that in the first example, private access specifier was not written. So though C++ is providing you this additional security or additional feature, having private as the default access specifier for your class members, it's generally a good practice to have explicitly write private as the access specifiers and defining your members inside of private access specifications. So in the another example, if you just closely watch here, so this is again private member and these are your public member because access specifier is public over here. Because there is no access specifier, so this becomes private member. This and this both are same because private is explicitly written over here, and again these are your public members. Again this one and this one is again similar, so all these three examples are similar, but in the third example I have declared my public members first and then private members. So the order does not matter over here. So for C++, importance is of your access specifiers, but generally again people usually declare their private members first, so that while reading they get more importance, and they usually write public or protected after the private members are declared. But again that is something individual's choice, so technically it doesn't make any difference in the program. So as earlier discussed that we have another access specifier as protected. So here's one example that how all the three can be combinedly used in one of the class declaration. So I have private, public, protected, all three access specifiers in this example. And then after the scope resolution operator, that is this colon, I can have my variable and function declarations like this. Another form could be wherein I have not written any access specifier over here. So by default, these two members are considered as private. Okay. Now for our current study, we are just going to concentrate on private and public, and we're going to touch upon protected as the access specifier when we are going to learn about inheritance. So here is one example of how we can declare a class and create an object of a given class. So I'm declaring a class as a vehicle, and then I have public members inside this class as in total wheels and float mileage. So these are two data members which are of type public, that is those can be accessed from outside of the class. Inside of my main function, I have created two objects v1 and v2 of type class vehicle, and then I can access my data members with the help of a dot operator. So I can write v1, that is object v1 dot total underscore wheels is equal to 4, and after that I am initializing v1 dot mileage equal to 110. Similarly, I am doing the same thing for v2 with these two statements. Now, interesting thing what we need to understand over here is that when this line is executed, so v1 and v2, these two objects are created. Okay. Now, because these two objects v1 and v2 are of type class vehicle, so if you check, this class vehicle has two data members. Okay. So a separate copy for these two data members will be created for v1 and v2. Okay, so this is your total wheels for v1, and then mileage, sorry for the bad writing, and again total wheels for v2, and again mileage for v2. Okay, so using the dot operator, I can use v1 dot total underscore wheels, then again v1 dot mileage. So when I'm writing v1 dot total wheels is equal to 4, so 4 will get stored over here, and when I'm writing v1 dot mileage is equal to 110, 110 will be get stored over here. Similarly, in the next statements, I'm writing v2 dot total wheels equal to 2. So we'll have 2 over here, and then v2 dot mileage equal to 80. So 80 will be stored over here. So for each copy of an object of class vehicle, these two data members will be created like this. So if I'm creating an object of class vehicle as x, then again I'll have two more variables allocated for this object. So this will be total wheels and then mileage, and those can be accessed using the dot operator, like x dot total wheels and then x dot mileage. So coming back to this program, after this we have cout statement. So I have cout, then v1 dot total wheels, so that is 4. So 4 wheeler with v1 dot village, that is 110. So 110, then we will have mileage and then end L. So the first line will print 4 wheeler with 110 mileage. Similarly, we have v2 dot total wheels as 2. You can check it over here. So after that, this string will be printed wheeler with. Then we have v2 mileage, that is 80. If you can check over here this value, and then we have string mileage. So the second line will print two-wheeler with 80 mileage. So if you can just compile this program, you'll get this output. So four-wheeler with 110 mileage and two-wheeler with 80 mileage. Just notice that we have written 0 at the end over here. So we are just instructing compiler that main function is going to return an integer value. So return 0. So 0 is nothing but an integer. So technically here it is not really making any sense, but in case you have any command line arguments or in case your program is executing at the command line, so this return value might make a sense. So it's not compulsory to write int always over here. You can either write void or you can write float. So that really depends on your program requirements. So now let us continue. I am just going to speak about scope resolution operator before we continue with the member functions while explaining them as a part of a class. So next important topic is scope resolution operator. Scope resolution operator is nothing but two colons like this. So scope resolution operator defines or explains scope of a variable or of a member to the compiler. In this example, I am using variable x of type integer and I am initializing it to 10. Notice that this becomes a global variable because I am not declaring this variable inside of any function. However, inside of main function, I am declaring the same variable x with the same type but with different value as 20. So for the compiler, these two variables are different. This x is a global copy and this x is local copy. So though the variable name is same, for compiler these are two different variables altogether. Now when I want to refer to this copy, okay, inside of main, that can create ambiguity as well. So when I am going to write cout x, so for compiler it might create a confusion then, because local variables are given the preference. So when I'm going to write just simply x, so compiler is going to refer to the local copy of variable x. But when I'm using x along with scope resolution operator, in that case compiler is going to refer to the global value of variable x. So output of this program will be global x is equal to 10, and then on the next line, because of the slash n, it is going to write local x is equal to local x is equal to, because I'm referring to a x simply over here, so it is going to refer the local value, that is 20. So this is my output. Now scope resolution operator is more important or more relevant in our study when we are going to talk about declaring member functions. So we're just going to check that topic in the next slide. So when I have to define my class member functions, so there are two ways to do it. One is defining class members inline. So that is when I have my class X as an example over here. So I'm using public as the access specifier and foo is the function name. So if you just check over here, so immediately after, so this is my function definition of the function foo. So I'm just printing over here a hello message. In this case, I am defining the function inline. That is, I'm defining those member function inside of my class definition. So this is my class definition. So you can have n number of member functions declared like this in line in your class definition. However, again, it's not a standard practice. Reason being, in case you have, let's say, hundreds of different member functions, in that case your class definition can be very huge and it might not be good idea because it might be difficult to read your class definition quickly. So usually what good programmers do is that they declare their data members and data functions inside of class, and then they define the member functions using the scope resolution operator. That is something that we are going to check in the next slide. But however, continuing with this program, so after my class definition is done, inside of main I have created object A of class X, and then I'm accessing my member functions using a dot foo. So this line is going to print this message, and it is just going to return 0 over here. So output of this program is nothing but this string. What we wanted to understand is how member functions can be defined in line. Now in the next slide, we are going to check how we can define class member functions using scope resolution operator, which is a cleaner way to define your member functions. So I'm taking the same example. So I'm having my class X, then I have public declaration of function foo. So it is not going to return anything. So I have return type as void. Now notice there is a semicolon. So this is nothing but the function declaration of function foo. Okay. Now in order to define that function, what I'm going to do is I'm going to write return type of that function, because here it was void. So this is the return type, and then I'm going to use a scope resolution operator, that is dot dot, and I'm going to define scope of this function to class X. So to compile that, I'm going to tell that this function is part of my class X. So only thing that is changing is X colon colon. Okay, that is X scope resolution operator. And then I have my standard definition. So my code inside of this parenthesis, and then inside of main, I'm creating one object, a of type class X. Then I'm just going to call it normally using the dot operator, that is a dot foo, and then there's a return 0 at the end. So what you need to understand over here is that your program could have another class, let's say class Y, and it could have a same function name, let's say public, then void foo, parenthesis and semicolon. So because now you have two different classes, but then there is a function name which is identical, in that case when you are required to define those functions, you have two choices. One is you can have inline function definition in both the classes, but we know that it's not a cleaner way to do. So you can do it alternatively using the scope resolution operator. So similarly to this code, you can have your void, then because you're writing the function definition for class Y, so you're going to write the class name, then scope resolution operator, then after that your function name, and then you can write your code inside the parenthesis. Now let us check how we can parameterize member functions, or how we can send parameters to the member functions. So let us try to understand that with help of this example. I am defining a class named maths, and then I have public data members, variable a and b of type integer, and then I'm going to use a function add, which is going to return me one integer value, and it is going to take two values as parameters, int a and b. Now another point I want to make here is, because this is just a function declaration, variable names are not required over here. Okay, you can just simply write int comma int, because to the compiler you are just going to tell that I am creating one member function called as add. It is going to return me value of type integer, and I'm going to supply two values both of type integer to it. So int comma int. But here just I am writing these variable names also just to simplify the understanding. And then with the help of a scope resolution operator, I'm defining my member function. So int my class name maths colon colon function name, and then here in the definition I'm going to write these variable names. So inside of my function definition, I'm writing int c, creating another variable and adding these two variables, so a plus b, storing that value into variable c, and I'm going to return that value, so return c. So this completes my function definition. Now inside of main function, I'm creating one object m1 of class maths. So when m1 is created, okay, it is going to have these two data members. Okay, so inside of m1 I'm going to have value a and b, which are public, hence those are accessible directly. So I'm writing m1 dot a is equal to 10 and m1 dot b equal to 20. So value 10 and 20 will be stored to the memory allocated for the object m1. And after that, we have on cout statement where I'm just writing addition of m1 dot a, that is 10, and m2 dot b, which is 20, then is, then I'm writing m1 dot a, m1 dot b. So I'm supplying two values, that is 10 and 20, and it is going to return me addition of these two numbers. So addition, that is 30, will be replaced over here. Okay, so output of this program would be addition of 10 and 20 is 30. Now in the next topic I'm going to touch upon this topic, that is inline returns. So in case you have seen in the previous example, we had created this variable int c equal to a plus b, and then I was returning value of c. So instead of doing that, what we can do is we can write the addition inline, and because these are two integers, so addition of two integer is going to give me integer only. So I'm just going to return it inline, that is a plus b. So what I'm doing over here is I am not creating one additional variable just to perform one addition operation. So these are inline returns, so you can have any kind of formula over here. You can use parenthesis, or in fact you can have another function call also over here. So it depends on your programming requirements. But inline return is something really useful, and it reduces the amount of variables that you might require in your code. Now let us talk about private member functions. We have seen that we are able to access public member functions directly from the other members, but how we can access or perform operations on your private member functions, especially data members and your member functions. So let us try to understand that with the example of this class. So I'm having this class maths, then I'm having this private members. Okay, one is variable c of type integer, and then I have a add function which is going to perform addition on two integers. Again, if you notice, a and b is explicitly written over here because this is my inline function definition. So variable name will be required over here, and then int a comma int b will be added into variable c. Okay, so addition of these supplied variables will be stored into private data member c. Okay, now because c is a private data member, it cannot be directly accessed. So what we are doing now is we are creating another member function show, which is just going to take two values just for the display purpose, and it is going to use variable c as well inside the code. Okay, so this is another inline function definition of function show. So what I'm doing here, I'm calling add function directly, and I'm supplying values to it. Now show function is able to make this call because all the public member functions have access to the private member functions of the same class. Hence this call is valid over here. However, the same code cannot be written directly in the main functions or any other functions as well. Okay, so inside of main function now, let us see what is happening. So I have my class name m1, so I'm creating one object m1. So m1 is going to have variable c, which is a private. Then it is going to have two more variables a and b. So a and b. So notice that c is the private data member and a and b are public data members. Now because a and b are public data members, so I can directly write m1 dot a and m1 dot b. However, I cannot write m1 dot c because c is not accessible from outside of the class. Okay, so in order to access variable c, what most I can do is I can call m1 dot show. Again, why show we are able to call from here is because show is of type public. If you can see over here, it is public member function. I cannot write m1 dot add directly here because add is the private member function. So what is going to happen here is I'm passing m1 dot a and m1 dot b, that is 10 and 20. So these variables will go here. So 10 and 20 will be passed here. Then I'm writing add 10 and 20. So call will be transferred to here, and then addition will be performed here. Value will be updated as m1 dot c equal to 30. So m1 dot c will become 30. So this c becomes 30 now. And then when execution of this function is completed, after that we are writing, compiler will come back to here and then it will print this line. So addition of variable a and variable b is c. So it is nothing but addition of a, that is 10, and b, which is 20, is c, that is 30. Another important thing to notice over here is I'm just writing a, b, c directly. I don't need to write my object name over here. Okay, because you might have multiple objects like m1 and m2. So whenever m2.show is being called, that time this a and b are going to refer to the values of object m2. Okay, so this is just important point I wanted to make over here. So object name you cannot write inside of your class definitions. We're just going to cover this last topic on arrays within class. So I'm having this class name array demo, and then I'm having one integer array of size 6. I'm calling this integer array as a. So notice that this is my private member now, and using public as the access specifier, I'm having two member functions. One is get elements and other one is show. So get elements is nothing but it is going to help me accept 6 values from the user. So inside of a for loop, I'm writing c in, and this for loop is starting from 0, it will go till 6. So for all the values 0, 1, 2, 3, 4 and 5, it is going to store integer value that user is going to supply. And then inside of function show, I'm just going to reprint those values. So I have a similar for loop, and I'm just going to print those values for all the array elements using cout. Okay, so inside this loop will start from a of 0 and it will go till a of 5. So inside of this loop, it is going to cout, or it is going to print values from a0 to a5. So after the class definition, I'm having my function main, and then I'm creating object obj of type class array demo. Now once this is done, I am calling object dot get elements first. So with the help of this line or this function call, I'm going to execute this code or this function, and it is going to store values for object obj dot a0 to a certain value, then a1 to a certain value, and so on. So all the array elements can be accessed like this. So obj dot a0, obj dot a1, obj dot a2, and so on till obj dot a of 5. So all the values will be stored at these memory locations, and similarly with the help of object dot show, I can print those values. Okay, notice that I have access to the private array a. So I'm just directly writing here. So once variables are accepted using this value, using this line, then I'm just going to reprint those values using my another function object.show. And with the written 0, my program will end. So what I suggest now is just play around with the examples that we have shown in this video. You can download the samples code from our website so you can have quick access to the code. So we are going to cover various topics related to functions in C++, like function overloading, friend functions, call by value, call by reference. Few of these topics you must have already know from C language. However, we are just going to touch upon those points, and we are going to add few more concepts which will be useful in learning C++. So let's begin with the video. So main function is the most important function when you write your C++ programs. This is the first function that is called by the compiler. So if you check here, there are three ways you can write the main function. One is you write int, the return type for the main function, then main, and then parenthesis. So I'm just writing a semicolon over here because we are just talking about the declarations. So this is a standard structure of a main function. I have a return type over here int, then main with the parenthesis, then you have your statements inside of these curly braces, and at the end you have a return 0. Now we are passing 0 over here because the return type of this function main is int. So another way in which you can write your main function is using these two arguments. You must have seen these two arguments when we talk about command line arguments in C programming videos. So I have added that link in the eye icon. You can click if you want to check that. So when you have these arguments, you can supply command line arguments to your program. So this first parameter is number of command line arguments that your program have, and these are the actual command line arguments. So these can be multiple, and you can use those arguments using index of parameter argv. You technically can have a void main instead of int main also, but there are certain conditions wherein like your program should not have error, and there are a couple of 3 or 4 points. But I think it's a very good and standard practice that you should always write int main instead of void main. First of all, it's a good practice, and it gives meaning to your function in a way that you always know that your program is going to return something rather than nothing. So you must have observed that in case your program gets an error, so you get additional error on some compilers that your main function should return a value. On old versions of CPP, you get a warning, and in some of the compilers wherein in case your program has one error, it will show two errors. Out of that, one will be for the return type of int. But anyways, to simplify things, I'll suggest you to always write int main and then return some value to the compiler, like return 0. Now next is function prototyping. So what is function prototyping? Basically you declare your function first and then you define your function. So typical form of declaring your function is the return type, then your function name, and then in the parenthesis you have your function's parameter list. So here's one example. I am writing one function declaration as float, which is the return type for the function division, and I'll be supplying two parameters to it. One is float x and other one is int y. Now important thing is that because this is a function declaration, so you can skip writing variable names here. So this is optional. So variable name is optional. So these two are same function declarations. So I have skipped variable names over here. So this is valid and it's a standard practice to write it like this. And when you make a function call, I have created one float variable. I am naming it as result, and then with the equal to sign, because this division function is returning a float variable. So whatever the value that this function is going to return, it will be stored into results. So these are two parameters I'm supplying. First one is float and another one is int. So there could be some instances wherein your function might not require any arguments to it or may not require any parameters to it. So in that case, you can write void. You can also write empty parenthesis like we usually write in case of main function. So here it's a function called as display, which is returning me void, as in it's not going to return me anything, and I'm also not passing any values to it. Now in case of function calls, there are two types of call which are usually made. One is call by value and other one is call by reference. So call by value is very straightforward. You have original value passed to a function and it cannot be modified, as in when you have, let's say, function add and you are passing to integer values to it, int x and int y. Whenever, and let's say suppose you have your function definition over here, And whenever you're going to make a call, let me just add return type also over here as int. So add is a function which is going to return me integer value, and it is going to accept two integer values x and y. So when you're going to make call for this function, let's say 10 and 20, or let's say you have two variables, a is equal to 10 and a equal to 20, and b equal to 20, and then here is your call add a comma b. So when this call is made, a and b are going to retain their original copy, and values of a will be copied to x, and value of b will be copied to y. So both these variables are maintaining different copies of the same value. So when you pass values like this, the method is called as call by value. Now, if you just closely observe, we just have two values, but we are using four variables in this example. So it is a bit of extra overhead that we're carrying, because compiler also has to create two variables whenever this function is called. Okay, so let's say you have 10 calls made to this function, then technically you are going to create 10 multiplied by 2, that is total 20 integers for all those 10 calls. Now there's another method which is called by reference, wherein you can pass a reference to the variables. So assuming this to be a function, so here is my function definition. It's this is return type, and then this is your function name. Now here I am creating a pointer variable, and then another pointer variable, and whenever I'm going to make the call to the function, I'm going to pass address of the local variables. Okay, so in a way these statements are, because this value of x will be referred over here and value of y will be referred over here, so this is nothing but similar to writing x star x is equal to address of x. This address of x is this variable, and similarly star y is equal to address of y. So we know that how to read it. I have given you a technique how to understand use of pointers, so you can just briefly review that video. I have added that link in the I icon. So if you just read it as value at the rate y, so whatever the value that is stored at this location will be replaced over here. Okay, so let us try to understand this with an example. So in case of call by value, let's say I have a class math, and then I have a public function change, to which we're just passing single value float. So here is the function definition of function change, which belongs to class math. So I'm accepting one float variable, that is y, and then y is equal to 5.5. This is something that I'm setting inside of function definition. Now inside of main, I'm creating one object m1 for the class math. Then I'm having this local variable float y, initializing it to 3.5. Now if you check what I'm doing over here is I'm calling my public function change, and I'm supplying it 3.5 as a value, which is value of y. The function is being called with the help of object m1. So when 3.5 as a value is passed over here, okay, so technically whenever I am writing y is equal to 3.5, so this 3.5 is overwritten by 5.5. Okay, so what is happening over here is, because this call is initiated from m1, so m1 dot y is becoming 5.5. Okay, now in the next line I'm writing value of variable y. Okay, because y is a local variable over here. Okay, it has nothing to do with value m1 dot y. So the output of this program would still be 3.5, because this call was made with the value. Okay, So 3.5 has as a value has returned over here. Okay, now let us see the similar example in the call by reference. We are going to take example of swapping of two numbers, okay, which is a very popular program, and questions on these are asked couple of times in the programming interviews. So straight away I'm having this function called as swap. So to this function swap, I'm providing two integer pointers. So I'm specifying int address of x and int address of y. So whenever a call is made like this, swap x comma y, so values which are stored into variables, these are which are 10 and 20. So address of these variables will be passed here. Okay, so address of 10 and 20 for the values which are stored into variables x and y. So address of x and y is passed over here. So because these are references, I am creating just temporary variable over here for the swapping. So I am storing value of x into variable temp, and then I'm swapping x with y. So value of y will go into x, and then finally the previous value of x which was stored into temp will be copied into y. So in the first step, so temp will become 10, x will remain as 10. Then after execution of next statement, x will become 20, temp still is 10, and y is still 20. And in the final statement, we are replacing y with value of temp, that is 10, and temp still remains as 10, and x is already changed in the previous statement, that is 20. So if you notice, after execution of the last line, value of x and y have got interchanged. Now important thing that is happening over here is these values are getting changed because we have sent a reference of these variables. So when you just print these values, so it will print 20 over here and 10 over here. So output of this program will be like this. Okay, so important advantage of call by reference is that the compiler doesn't create multiple copies. Even if you have, let's say, 10 calls, only two variables will be created which are only your local copies, and these are just acting as the pointers. So we are just referring to these values directly. So however the operation is being done outside of the local scope, copies new copies of the variables are still not created. So call by reference is very useful when you're working on memory constraint, when you have a good amount of memory constraints, and in case there are multiple calls, even in those cases call by references are found useful. And then we have one interesting topic that is written by reference. So function declaration, you do it with int and then ampersand, then you have your function name. So let's say this as an example, you have int ampersand show and you're just returning num. So by writing this, you are sending reference value of num to the calling function. So inside of main, let's say I am calling show equal to. Now because you are returning reference to this variable, so you can use assignment operator to this function name. So this statement is similar to address of num is equal to 5. Now I'm just writing as this because technically address of n might not give you the correct understanding over here. So we are just going to read address at the address of variable num. Okay, so this 5 value will be stored to the address of variable num. Okay, so again, this is very interesting when you are required to do these kind of operations. So you can use return by reference. So after this, once this statement is executed, when the call is made, okay, and a reference to the variable is received, okay, so this assignment will be performed. And after that, when you write num, you will have value 5. The compiler will print value 5. So here is the output. It will print 5. Then we have inline functions. So inline functions is nothing but that the compiler places copy of code of inline function at each point wherever the function is called. Inline functions are suitable when you have small function definitions. In case you have large function definitions, that will increase your definition point, that will increase your execution time. Important thing about inline function is that in case you have made a call to the larger function, so every time you're making the call, the compiler is going to replace those code lines, and it will increase the execution time for the compiler. So when we write inline functions and whenever we make the call, so it's just a request to the compiler, it's not a command. So compiler might not always do inline function calls inline whenever we are calling them. So let us just try to understand this. When you want inline function to be used, so you just need to write inline as a keyword in front of your return data type. This is your function name then, and then you have the argument list of your function. Then you have your function definition over here. So in this example, what I have done is I have created one inline function with the help of keyword inline. Then I have one return type as int. I'm calling the function as min, that's minimum, and I'm supplying it two variable integer a and b. And in return, I am just comparing these two numbers with the help of conditional operators, and whichever is the smaller value, I am returning that. So either a or b, whichever is the smaller, will be returned. Now instead of main function, if you just take, I have this calls. So this statement, okay, so this statement will be replaced over here by the compiler at the runtime for all these three statements. Now because in this case it is a very small function, so for the compiler the operation would be easier. But in case you have, let's say, large number of statements over here, let's say this function has thousands of lines, so in those cases it's not advisable to have your functions in line. So inline, so using functions as inline makes sense only when you have short amount of or small amount of code. Again, as I mentioned in the previous slide, so inline is the request to the compiler. It's not a command. So in a way that is good because compiler will get to know using the function definition that it's a process intensive function. So in those cases, he might not replace code lines in line, or the compiler will decide whether to have this function in line or not. That is something that compiler will decide based on the performance requirements. Whichever the compiler finds best, it will do. Either it will convert those lines in line or it won't. So in this example, your output is simply this. It is just going to compare whatever the values that we have supplied, and it is going to print minimum of those values. So in case of 10 and 20, we have printed 10, and in case of 100 and 0, we have printed 0, and in case of 15 and 16, we have got the output as 15. Now let us quickly check about different functions provided in C++, which are under math.h header file. So math library functions which are commonly used are ceil function, that is ceiling. It gives you ceiling value. It rounds provided number n to the smallest integer, and the smallest integer is usually not less than n. So for example, when you supply 5.6 as the value, so ceiling value of 5.6 is 6, and then when you supply minus 5.6, the ceiling value of minus 5.6 would be 5. The similar to ceiling, we have floor. Okay, so floor value gives you a rounded value for the variable n to largest integer, which would not be greater than n. So just to simplify this, ceiling values are something like this. So this is your ceiling value and this is your floor value. Okay, so your supplied value would be somewhere here. Okay, So when I say 2.1, so ceiling value is 3 and the floor value is 2. Okay. Now in case we are talking about the minus or the negative values, so in case of minus 2.1, the floor value and ceiling value would be, the floor value would be minus 3 and ceiling value would be minus 2. Okay, because we are on the other side of the scale. So this is how floor and sill function would work. We also have other trigonometric functions. So cos x will give you trigonometric cosine of x. Similarly, we have sin x, which will give you trigonometric value of sine of x. Then we have similarly tan, which will give you trigonometric tangent of x. Similarly, we have exponential value of n. So it will give you e raised to n. Then you have log n, which will give you natural logarithm of n with the base e. Then you have log 10n, which will give you logarithm of n with base 10. And then we have one power function to which we supplied x and y, or two variables. So it gives you x raised to y. Then we have SQRT function. So it gives you square root value of the provided variable. So in this case it will give you square root of n. And then finally we have absolute value of n, which is given by a function f abs. So abs is basically absolute value. So f abs, when you provide value n to it, it will give you absolute value of variable n. So this line will give you 5, this line will give you 0, and this line, so absolute of minus 5 is 5. So very simple. This libraries make your life quite easy. So these will become quite handy in case you are working on few complex mathematical operations. Then one important topic related to object-oriented programming is friend functions. So there could be instances wherein you might require access to private variables, but the functions which we are going to make call to those private members might not need to be your public member functions. So in that case, what you can do is you can use keyword friend. Okay, then you can have your return type function parameter, function name, and then the parameters list to it. So because you have given friend access to this function print, it can access your private members. Now notice that this is not your member function. Okay, this is open function. Okay, which has become friend to your class, and you have given access to this function so that they can access private members of your class. So inside of your friend function, what we are doing is it is receiving one object of type class math, and I'm updating m dot weight, which is a data member of your class math. I'm increasing its value with 10. So this statement is nothing but m dot weight is equal to m dot weight, that is existing value of the weight, plus 10. And once this execution is done, I am returning m dot weight. So now let us see what happens when instead of main I'm creating this object and calling this friend function. So I'm passing m over here. So call will be made here. So m dot weight will be increased to 10, and this value will be written over here. So 10 will be written over here. Okay, and after that the program will end, and your output of this program would be weight colon 10. So only important thing to notice here is that friend functions need not be your class member functions, but once you give access to an external function by adding a friend to it, you give access to your private data members. So in a way, if friend functions are not handled carefully, so that can also become a security issue to your private data members. So friend functions need to be used very carefully. Then we have final concept in this video is function overloading. So function overloading is nothing but the same function name but with different parameters or return types. So if you just check this example, I have three variables ABC of type integer. Then I have two function names which are both same. I'm calling both as add. But if you just notice, the first function is accepting two variables of type integer while other one is accepting three variables of type integer. Now this is the concept of your polymorphism, that is it gives different meaning to the same things. So in this case we have same function name, but depending on your function calls, in case I am passing two variables or three variables, the appropriate function will be called. So if you check this function definition of both the function, I'm just returning a plus b over here when two variables are supplied, and in the other function when three variables are supplied, I'm returning a plus b plus c. So inside of main function, when I'm just updating value of object m1 which is created over here, so I'm updating value of variables abc with 10, 20 and 30 respectively. So if you just check over here in the next statement, I'm making call to function add. Here I'm passing two variables, so call to this function will be made. So this will return me addition of 10 and 20 is 30. And in the next statement, what is going to happen is that it is call will be made to this function, and it is going to print addition of 10 and 20 and 30 is 60. Okay, and your function will end over here. Now see, just important thing to remember over is that your function can have different parameters and different return types, and depending on the call, the compiler will decide which function to be called. With this, you can add a wide range of function variations in your class. You can extend this class by adding functions which can have two float values, or you can also have add and you can pass two character strings which will concatenate those supplied strings and send you a single string. So that is how you can have single function name, but depending on your parameter list or return type, you can have different copies of functions. So constructors are very important to object-oriented programming, and these are basically special functions which have same name as the class name. And constructors are invoked whenever an object of a class is created. So let us try to understand what constructors are with the help of an example. So I'm having one class calling it as vehicle. It's having two integer variables a and b, and then I'm having this constructor naming it as vehicle, and I'm not passing any parameters to it. So this is nothing but my constructor declaration. Now, similar to function definition that we have for public member functions, we can have function definitions for your constructors too. So in this case, this is your class name and this is your constructor name. Now, because there's no parameters over here, I'm just initializing these two variables with value 10 and 20. And then when I have my main function, I'm creating object v1 of type class vehicle. So once this object declaration is done, so v1 dot a is initialized to 10 and v1 dot b is initialized to 20, because call to this constructor is made as soon as this object is created over here. Similarly, if you have another object, let's say v2, whenever you declare this object and memory is allocated to that object and its data members, so call to the constructors will be made and v2 dot a will become 10 and v2 dot b will also become 20. So notice that constructors do not have any written values. Those are special functions in object-oriented programming, so they don't have any written value. Similar to parameterized functions, we can have parameters that we can pass to the constructors. Once the parameters are passed, Call to these constructors can be done implicitly or explicitly. So let us try to understand how parameterized constructors can be created, and also how we can make implicit or explicit calls. So I'm having this class numbers, two numbers of type integer a and b, and then inside public I have constructor numbers to which I'm passing two parameters int. And then I have another member function calling it as display. It is returning me void, and I'm also not passing any parameter to it. So here I'm just accessing my private members a and b, just printing those. Now inside function definition of my constructor numbers, this is my class name. This is the constructor name, which is same as the class name. So two variables here, x and y. So I'm just copying values which are passed at the time of object creation to the private members a and b. So inside of main function, I can have a constructor called when an object is created, and this is my explicit call wherein I'm specifying values like this. So this is my class name, then my object name equal to constructor name, that is the function, and parameters. So this method of calling is called as explicit call. And in case of implicit call, instead of this equal to and function name, I can simply pass these parameters 20 and 30. These are my initial values for the functions. So numbers, then my object name, and then inside the parenthesis, I'm passing initial values which I can use to pass to my constructors. So whichever way you're comfortable, you can either make explicit call or implicit call, whichever you find easy to use. Now, once this cout is done, I am calling my member function display. So n1.display, what it is going to do is going to print this line, but n1.a is, we know that it is 10, and n1.b is equal to 20. So this line will print a equal to 10 and b equal to 20. Similarly, when n2.display is called, so n2.a and n2.b will be referred here, okay, because call is being made via object n2. So hence, in the second line, it will print a equal to 20 and b equal to 30, because we had passed 20 and 30 these values to the constructors. So here is the output for the program. Then next we have parameterized constructors inline. So this is similar to inline function declaration that we had done for member functions. So instead of writing function definition outside of class, I'm just writing it inline. So nothing much to explain over here. So this is just definition that I have done inline. So it is the same program as the previous one. So output of this program would be equal to 10 and 20, because 10 and 20, these parameters are passed to the constructors, and values of x and y are stored into a and b. So next topic is multiple constructors. We know that in object-oriented programming, we can have same function name with different parameters. So same adaptation is done over here. Like in case of function, we can have same function name and multiple parameters. Similarly, we can have constructors with different parameters. And depending on the parameters that are being passed to the constructor, the respective constructor definition would be called. So let us take one example for the class numbers. Again, I have two integer variables a and b, and in public section we have a simple constructor which does not have any arguments, and it is just initializing values of a and b to 0. And then we have another copy of the constructor numbers, that is where we are passing two arguments, one is x and y, and we are using those values to initialize values of a and b with x and y respectively. And then we have another function display, which is just going to print value of a and b. Now inside of main, if you check, I have created one uh, object n1 of class numbers, and because I have not passed any parameters over here, so this constructor will be called. So n1 dot a will become 0 and n1 dot b will become 0. Then we have another object that I'm creating, calling it as n2, but here I'm passing 10 and 20 as additional arguments to the constructor. So this constructor will be called for n2. So because of this function definition, n2 dot a will be initialized to 10 and n2 dot b will be initialized to 20. And after that, we are just calling this n1 dot s display function and n2 dot display function. So this will just print values of a and b for respective objects n1 and n2. So this will be the output of this program. So a and b are initialized to 0 for n1 and a and b are initialized to 10 and 20 for object n2. Then we have constructors with default argument. It is very simple concept. So in case of constructors, we specify some value to one of the argument. So even if we don't pass this second argument, so this value will be utilized inside of your constructor definition. So this is my constructor definition with one default argument, and then I have my display function over here. So inside of main, I am having two objects created, n1 and n2. So to the first object n1, I'm just passing single value to the constructor, that is 10. So what is going to happen over here? So this, for this definition, x will be passed value as 10, and because we have not passed any second argument, so y will be considered as 2. So value of a for n1 will be 10 and value of b for n1 will be 2. So after execution of this statement, n1 dot a will be 10 and n1 dot b will be 2. Then we have a second object n2 wherein I am passing two values. So 10 will be copied into x, and because we are passing second argument, so this value will be overwritten and y will be considered as 20 over here. So after this execution, a will be initialized with 10 and b will be initialized with 20. And once this initialization is done via constructor, so these statements will be executed and it will give you this output. So these are values of n1 object and these are values of n2 object. Now the next topic is copy constructors, a pretty simple topic. Here we just pass existing object to the constructor of the same class. So in other words, it gives reference to its own class as a parameter to the constructor. So the same example we are continuing with the class numbers and variable a and b. In the public sections, I have a constructor which I am just initializing to 0 values, and then I'm having another constructor with one default argument, and I'm using both arguments to initialize values of a and b. And then we have another constructor wherein I'm passing a reference to the another object. Okay, so number at the rate I. So by using this reference, I'm using data members of object I directly using the dot operator. So I dot a I am using to initialize value of a, and then I dot b I am using to initialize value of b. Then we have this display function. Inside of main, what I'm doing is I'm creating one object n1 and then I'm supplying two values to it, 10 and 20. So after execution of this statement, n1 dot a will be initialized to 10 and n1 dot b will be initialized to 20. And after that, I'm creating another object n2, and because I'm supplying another object of the same class numbers, so using the referenced value, this constructor will be called, and value of n2 dot a will become value of n1 dot a, which is 10, and value of n2 dot b will be taken from n1 dot b, which is 20. And after that, I'm just printing these values using n2 dot display function. So this will print a is equal to 10 and b is equal to 20. So this is the output. So using copy constructors and the reference to the previous object, we have achieved this. Now, next important topic is the destructors. So destructors are basically used to destroy the object which are created by the constructors. The destructor function names are again similar to the class name, but they are preceded by the tilde sign, which is this. So this is your constructor and this is your destructor. If you just notice, I have added this sign over here. We call this as tilde sign. And inside of the constructor and destructor, I am just having this simple statement: constructor called and destructors called. So constructors are called whenever the object is created, and destructors are called whenever the objects are deleted. Okay, so what is going to happen is when this object is created, the constructor will called, then this statement will be printed, that is constructor called, and then during the execution the second statement will be executed, that is main terminating, because this is almost the second last line of the program. And when return happens and main function gets completed, the destructor will get called and it will print destructor called. So this is the output of this program. Now, important thing to know over here is that destructors does not have any arguments and return value. Another thing to notice over here is when exactly can destructors will be called. So a destructor function is called automatically when object goes out of the scope, as in when the program ends, or whenever the function ends, or when a block containing local variable is ended, or whenever a delete operator is called explicitly. For a class, there can be only one destructor. Like in case of constructors, we can have multiple constructors, but in case of destructors, we can have only one destructors, and those are default destructors. So the operators that we are going to discuss in this video are scope resolution operator, then pointer to member declarator, then pointer to member operator, pointer to member operator in another form, and then delete and new operator, which are memory allocation and deallocation operator. Then we have endl as the line feed operator and set w as field width operator. So let us check these operators one by one. So scope resolution operator we have already seen in the previous video when we were talking about classes in depth. So that is something that we are not going to check in this video. So other operators we are going to see. So we'll start with pointer to member declarator. So pointer to member declarator is used in conjunction with scope resolution operator and then a star. So let us try to understand this operator with the help of one example. So I have created this class math and I have a integer variable of public scope, and then inside of main function I am creating another integer which is a pointer, and I am defining my scope to this class math, and then it is a pointer. So this is how the compiler is going to process this information. So this is a pointer variable for a class math. In a way, this becomes your pointer to member declarator. And then equal to, we have ampersand math colon colon a. So a is public member of class math. As you can check here, a is public member of class math. So we are just specifying the scope here again, and then Using the ampersand, I'm saying that this pointer variable is pointing to variable a. So in a way, this is simply writing as int star pa is equal to address of a. Okay, if you just notice over, so this part is something that is being added in addition. Okay, which is just explaining the scope, or it is just resolving the scope over here. So when you create the object m1 of type class math, then when I write m1 dot a equal to 1, so I'm just directly assigning the value. So this is called as direct access method. And then when I write cout, value of a is m1 dot a, it will just print 1. And then when I write m1 dot star pa, which is a pointer to member a, and I'm writing equal to 2, so it is just going to overwrite the value of a, which was 1, with 2. Okay, now let us try to break down this part. So we have written m1 dot star p a equal to 2. So this is nothing but m1 dot value at a, which is equal to 2. So this is not a standard notation, but this is something that I recommend a way to understand how the compiler is going to execute this statement. Okay, so we know that we just replace star with value, and the value where the pointer is pointing, that we are writing along with the ampersand. So we read it as m1 dot value at the address of variable a, which is equal to 2. So this statement is going to overwrite value of a. And once this is done, so we are just going to print value of a is m1 dot a. So here it will print 2 instead of 1. So output of this program is value of a is 1 and value of a is 2. Now the next operator is pointer to member operator. So this is used by dash and greater than followed by a star, or alternatively it can be also used as dot and star. Now let us try to understand it with the help of an example. So this is, I'm just extending the previous class. So class maths has this public variable a, and then I have a public member function named as add. So in this function I'm just printing this cout add and then parenthesis. Now when I'm going to create a member function outside of this class, I am just writing it in this fashion. So let me break down this statement for you. So this is your scope resolution, that whatever here is belongs to my class math, and it is nothing but a pointer to a member function. So that can be identified by this parenthesis, which are outside of this parenthesis. Okay, so this is nothing but a pointer pointing to a member function. Now when this pointer is created, we need to specify where it is pointing to. So I'm writing equal to @math colon colon. This is again specifying our scope, and then I'm writing add. So add is nothing but my public member function. So here I'm creating one member function pointer which is pointing to this particular member function. Now once this pointing is done, I am recreating the variable that we were used in the previous example. I am creating one pointer to member which is pointing to a public member of the class. And then inside of main function, I am creating m1 as the object of class math, and then one pointer to object with the help of star operator. So this is object pointer equal to new math. So this is, we are writing inline. Now to access the member function using your pointer to member function, we can use a dot operator then a star, which tells compiler that it's a pointer, and then this pointer to member function. Now notice that we always write this whole statement inside of a parenthesis. So that is how we can write separate parenthesis which denotes that it's a function. And doing the same, we can add parameters if required. So in case this add function has parameters and we have this uh, pointer to member function, then we can specify our parameter list over here. So this is how we can access the member function using the pointer. An alternate way is to write this arrow symbol, which is combination of dash and greater than sign. But notice that we are using pointer. So this can be used when we have a pointer on both the sides, or when we have pointer on at least the left hand side. So PM1 is my object to pointer. So when I have to access data member of object to pointer, I can use this new operator, that is this operator. And what is going to happen over here is that using this, when you have a pointer to object on your left hand side, it is going to call the member of the class dynamically whenever it is required. So another statement is m1 dot star pa equal to 1. So this is how we are going to access the member data. So what we are writing over here is m1 dot value at the rate of a, because pa is pointing to a. So we are updating value of m1 dot a to 1 using the pointer variable. So here we are updating value of m1 dot a with the help of pointer variable, which is pointing to public member of class math, and it is being updated to 1. Now with the help of the pointer to object and the arrow, we are updating the same variable to 2. So we are updating the variable of object pointer pm1 to 2. Now on the next line, I am writing m1 dot star pa, which is nothing but value at the address of variable a. So it will print 1 for this particular part. And the next is pm1, which is my pointer object, and with the help of arrow operator I'm writing star pa. So this is still nothing but at the rate a, so value at the rate a, so which is 2 in case of m1. This part is going to print 2. Now to briefly again understand it in the memory how it is going to happen. So we have our class math, which has a variable a and a function add. I'm just writing it as like this, that it is a function and has some memory address to it. So these are two part of your class math. So when an object is created, let's say m1, so m1 has a copy of a and it can directly access member function add. However, when we are doing these two statements, in the first one, what is happening is that we are creating a pointer to member function. So what we are doing is we are creating p add as a pointer which is pointing to this function, and then another variable that we are creating or another pointer variable we are creating is pa, which is pointing here. Now when we create this particular object math m1, so we can directly use it with the help of dot operator like m1 dot a, or we can write m1 dot star pa, which is a pointer, okay, and is pointing to address location of your variable a, or address location of member variable a. Similarly, your member functions can be called directly with m1 not add, or because we have created a pointing, we can call it alternatively as m1 star p add, which is a pointer to member function, and alternately it is just going to call add function. And other way to do is using the arrow operator, but on the left hand side of the arrow there has to be a pointer to object. Okay, so star PM1 is pointer pointing to your class, and whenever a new operator is being used along with your class name, a dynamic object will be created. So using this star PM1, I can use the arrow operator and still access the public member and public member function. But for the important point to notice over here is that in order to use the arrow operator on the left hand side, it has to be a pointer to object. So using the arrow operator, you can write star PA and access the data member of the class math, and similarly you can use arrow operator again to call the data member function like this. So arrow operator, then your star p add, and then parenthesis. So notice again, in case your member function has parameters, those can be passed inside this parenthesis, and this is going to be the output. So every time the function is called, so add and add are printed. In a way, we were talking about two objects. So using individual pointer variables, we have specified values of variable a to 1 and 2, and that is how these values are printed over here, 1 and 2, using this statement. The next two important operators are new and delete. So using new variable, you can create variables dynamically, and these variables are added to heap memory. And using delete, you can delete those variables from the heap memory. So let us try to understand this again by one example. So this is our main function, and inside this main function we have created one integer pointer star x, and I'm writing x is equal to new int with the array size of 10. So when I'm writing x is equal to null, which is going to be not true in this case because we have created a pointer linkage over here. So this statement won't be true because x is not null here. So this statement will be skipped and we'll be going into else part, and in the else, memory is allocated is the message that will be printed. Now once this is done, I'm writing delete x. So x will be deleted from the heap memory from this point. So x, so notice that the dynamic variable of this integer array is created using operator new over here, and similarly using delete operator, it is deleted here. So output of this program is memory is allocated. Now let us understand few more points about new and delete. So new puts variables on heap memory, and delete removes variables from heap memory. When delete operation is performed, the pointer to object is not destroyed, but value or memory block pointed by the pointer is destroyed. Okay, so pointer itself doesn't get destroyed. The value or the pointer where it is pointing, that value is destroyed, and the memory block pointed by the pointer is destroyed. Okay, so just to understand this, let's say you have one pointer PA which is pointing to variable A. So whatever the memory is this A is using, okay, so when the delete operation is used, so this pointer is not deleted, but memory allocated to A is deleted, and the value that is being stored over here is deleted. So next point is non-pointer object or variables cannot be deleted. So let us take one example. So let's say you have variable int x. So you cannot use delete x on it because it's a variable, it's not a pointer variable. So when we try to delete normal variables using the delete operator, the compiler will give us the error. So here the error is type int argument given to delete, and it is expecting a pointer here. Now the next point is pointer to local variable cannot be deleted. So let us try to understand that with this example. So int x is a normal variable, and then I'm creating one integer pointer which is pointing to this local variable. So that pointing I have created using this statement, And when I'm trying to delete this pointer, the compiler will give me one runtime error. Now, why is that? So when we create this variables, so especially the x is a local variable that we have created in the program, and it is not a dynamically created variable. So this variable is added to the stack memory, and the variables which are into stack, those cannot be deleted even when you are using the pointers. Okay, so pointer to local variables cannot be deleted. So the members which are allocated dynamic memory can only be destroyed using delete operator. Okay, so that is very important point to remember. Now the next one is two manipulators. One is endl and setw. Both are used to format the data that we want to display on the output screen. It makes a life little easier for us. So endl is nothing but a line feed operator, and it just takes cursor to the next line. So suppose this is your output screen and you are printing A, B, C, and then you have one endl operator. So from this particular cursor position, the cursor will move on to the next line. Okay, so this is your output screen, and this is your first line, and this is your second line. So because you have endl at this location, cursor will move on to the next line. Now in case of setw, it sets a common width, or forces compiler to set a common width, so that a specified width of screen gets allocated to your variable to get printed, or your message to get printed. Now let us assume that your screen width is, let's say, of 5 character width. Then in case you just have two character width, let's say you are going to print x and y, so that x and y will be get right justified, so it will be aligned towards right. Okay, now this is really useful when you are going to display some tabular form of data. So using the setw, that will really make your life easy. In order to use setw, you'll require to use header file. You'll be required to use header file io manip, that is input output manipulators. Now let us try to understand this again by one example. So we have two variables a and b. I'm initializing both variables to 100 and 200 respectively. Then we have one cout statement where I'm writing setw4, and then I'm passing value of a. Okay, so in the screen what is going to happen is, let's say this is our output screen. Okay, so it is going to specify 4 character widths, and it is going to write 100. So 100 will be written like this. Okay, and then we are writing set w4, and then I'm passing value of b. So again 4 character widths will be specified like this, and 200 will be printed over here. Your cursor will be at this location, and because of this endl, the cursor will move on to the next line. And on the next line, what we are doing is we are specifying character width as 5. So 1 2 3 4 5, so 100 will be printed over here because we are specifying value of a in the cout statement. Similarly, then set width 5 will create additional character width. So these are my 5 spaces. So again 200 will be printed over here, and because of this endl, cursor will move on to the next line. Similarly, the set of 6 will be specified on the next line, and a and b will be printed. So output of this program is like this. So effectively your screen width has been started like this. So this was 4, then this was 5, so this was 5. Okay, so these are 2 character spaces, and then 3 because we had 6 as the character width over here. So 1 2 3, then 4 5 6. Similarly 1 2 3 4 5 6. So as I said earlier, setw is really useful when you have tabular information to be displayed you have some tabular data, or in case of you have some banking application where you are required to display a balance sheet where the information will be displayed in tabular format. So using the set width and endl will really make the formatting easier. So that was all for the operators that we wanted to discuss in this video. Alright, so now we'll quickly start about operator overloading, very important concept in object-oriented programming. So operator overloading is nothing but ability to provide operators a special meaning. So in simple words, if you have, let's say, plus operator, which is addition operator, and what it does is it adds two variables. Let's say you have, let's say, two int variables, so it will add these two int variables and it will give you output as another int variables. Now in C++, this plus operator can have a new meaning, like you can add two objects using the plus operator, okay, and it may give you something else, like it can give you the object again. So traditionally a plus operator will be performing its operations. So by default plus operator is going to perform its default operation, but to a user defined data types, plus operator can still be used. Okay, alternate way to do it is using the standard member functions, but that is still a unnatural way of doing it. When we use plus operator, for us it becomes really easy to understand that I'm just adding these two objects, okay, and it's more natural way of understanding. So it's a good advantage that we have in C++. Using operator overloading, we can write these type of statements. Another important point about operator overloading is that we cannot overload these operators. Okay, so dot star, scope resolution operator, size of, and conditional operators. So this is something that we cannot overload. Okay, for unary operators we can use operator overloading like this. So op is my operator. You can either write it like this, so your operator and then your variable, or your variable and then your operator. In case of friend functions, okay, so assuming operator to be your function name, so op is the operator name and x is the operand. So operand is what comes around the operator. So here this and this is the operand and this is the operator. Okay, similarly as we've seen in binary operator plus, so in binary operations your operands can be on either sides, your operators can be on the right hand side and left hand side, and then operator can be in the middle. Now when you have to access the same operator using the member function, you can use keyword operator and then the actual operator. So here x is your object, and operator op, or let's say for this example let's say operator plus, that will become your member function, and this could be a parameter. Okay, now when you have a binary operator, then x and y both should be the objects. Okay, so this particular line is for the example of binary operator, so this can be alternatively written as x plus y. Okay, if op is plus, of course. And again, when you have friend functions and you have, let's say, two operands or two variables, you can use it like this. So operator, then your operator, and then your two parameters. So let us try to understand how operator overloading can be done over unary operators. Okay, so again I'm taking example of class math. Then let us say we have three variables a, b, and c, and using operator keyword and the operator plus, I'm overloading operator plus over here. Okay, so what I'm doing is I'm just increasing value of variable a and b. Similarly, I am overloading operator minus, where I'm decreasing the value of my variables a, b, c, which belongs to class math. And we have another function display. It is just going to print value of a and b. So inside of main function, what I'm doing is I'm creating one object m1 of class math, and then I'm writing m1.a equal to 10 and m1.b equal to 20. So a and b is initialized with 10 and 20, Now when I write plus m1, okay, so this is unary operator, and this operator is going to invoke this function. So this statement is equivalent to writing m1 dot operator plus, okay. So these are my parentheses and then a semicolon. So these two statements are equivalent. So after execution of this statement, what is going to happen is uh, value of variable a and b is going to be increased. So m1 dot a will be incremented to 11 and m1 dot b will be incremented to 12. So when I write m1 dot display, these variables will be printed with the value 11 and 12. And when minus m1 is executed, so this is equivalent to writing m1 dot operator minus and the parenthesis. So what is going to happen over here is it is going to decrement value of a and b. So it will become again, so it will become 10 and 20 again, okay. So again, after writing m1 dot display, it will print value of a and b, which is 10 and 20. So here is the output of this program. So after execution of these two statements, value of a and b will be printed as 11 and 21. Oh, sorry, I made a mistake over here. Instead of saying 11 and 21, I said it 11 and 12. So a small mistake. So after execution of these two statements, value of a and b will become 11 and 21. And after execution of these statements, value of a and b will be printed as 10 and 20. In inheritance, there are multiple forms. So the most basic one is a single inheritance. So in single inheritance, we have one base class, okay, and then properties of this base class are inherited by a new class. We call that class as derived class. Okay, so these two important terms we need to remember. The class from where we are going to inherit data members or the properties. So that class is base class, and the class which is going to inherit those data members or properties, so that class is called as derived class. So we have two classes, A and B. So A is your base class and B is your derived class. So properties of A will be inherited by B. And then we have multiple inheritance, wherein we have multiple base classes, and properties or data members of these two base classes will be inherited via your derived class. So A and B are my two base classes, and C being my derived class. C is deriving properties or data members of class A and B. Then in case of hierarchical inheritance, we have single base class, and then properties of your base class A are inherited by these three different derived classes B, C, and D. And then in case of multiple inheritance, we have three classes. So this is your base class, and then this is your first derived class. So B is inheriting properties of A, and then we have another derived class. So C is deriving properties of B over here. So in a way, so C is inheriting properties of A via B. So in a way, it is inheriting properties of both A and B, but not directly, of course. And then we have a final type of inheritance form, that is hybrid inheritance. So we have one base class and other two derived classes which are inheriting properties of A, and then D is the third derived class which is inheriting properties of B and C. So in a way, properties of A are being derived via B and C. So this is one special case wherein a separate concept comes in, because A could be having, let's say, property small a, okay. So small a will be inherited here and here as well. So to compiler, it can give one ambiguity, especially when D is going to derive properties of B and C. So there's no problem when it is going to derive individual properties of B and C. Let's say b and small c are properties of B and C. Because D is going to inherit B and C, and because B and C have already inherited A, so there would be a copy of A here and also here. Okay, so now when we are introducing D over here, so to compiler it will become a problematic case because there is a clear ambiguity because A is going to be repeated. So this special case is managed by a concept called as virtual base classes. So that is something that we'll check in detail once we finish our study on other types of forms, that is single inheritance, multiple inheritance, hierarchical inheritance, and multi-level. So let us see each of these forms one by one, and we are going to also check hybrid inheritance, but in a slightly different form. So when we talk about hybrid inheritance, that is it could be single inheritance combined with multiple inheritance, or multiple inheritance with hierarchical inheritance. So it can be a multi-form inheritance. That is why the name is hybrid inheritance. So before we start, we also need to understand the modes in which inheritance is done. Okay, so when you have your base class A and derived class B, so when this inheritance is going to be made, so this inheritance can be of mode public or private or protected. Okay, so let us check what effect it can bring to the derived class when the mode is specified as public. So these three are my mode of inheritance, and these are my type of member that will be inherited. Okay, so when we have a public member in your base class, okay, and your mode of inheritance is public, then the inherited member remains as public. Okay, then when the mode is selected as protected, the public member will become protected, and when the mode is selected as private, then the public member of the base class becomes private. Then assuming that your base class has protected data members, and then in case of public mode of inheritance, the protected still remains as protected, and even protected as the mode of inheritance, protected member still will remain protected in your derived class. In the private mode, your protected members will become private. Now the final case is in case you have private data members, then in public mode or in protected or in private, because this member is private, in all these three type of inheritance modes, uh, these variables cannot be inherited, or these data members cannot be inherited because the basic scope was defined as the private. So that is the reason we use protected, especially when you are going to require to have your data members inherited to your derived class. So protected comes with a facility that your data member will be treated as private, but when you are going to use inheritance, those can be inherited in the derived classes. Okay, so that is one advantage. Now one most important thing to understand over here is your protected members once inherited with the private mode, then those cannot be further inherited, because in the first level of inheritance those are going to become private. Okay, but in other cases like public and protected, those will continue to remain protected. So this was about types of modes inheritance. Now we'll talk about the derived classes. So how to derive a class? Okay, so in case of derived class, or when you want to inherit a class, so the syntax is you write class, then your derived class name, then you write your visibility mode. Okay, so visibility mode is something this, so you can have visibility mode as public, protected and private. Then your base class name. So suppose we have A and B as your two classes, A being the base class and B being the derived class. So in this case we can write syntax as class B, which is your derived class, then colon, assuming now you're going to write visibility mode as public, so I'm writing public space your base class name, that is A, and then your definition of the class B starts. So this is the syntax, and just notice again here the semicolon over here. So here are two examples. So class car visibility mode as private, vehicle is the base class over here. So this becomes your derived class, this is your base class, and the visibility mode is private. So all the members which are part of your class vehicle will be inherited over here with the mode private. So your private members are anyways not going to inherit it. Your public and protected members, when those are going to get inherited in the class car, those will become private in this mode. And in the other example we have public as the visibility mode. So again the private members won't be inherited, but when protected are going to inherit, those will still remain as protected. Public will be inherited as is and will still remain as public members in the class car, which is your derived class. Now this is a special case when you don't define uh, any scope. So by default we know that private will be the default one. So here, so you can assume this visibility mode as private over here. So that was one small point. Now we'll try to understand a single inheritance with the help of one example. So this is one example. We are going to use our class maths. It will have one private data member A. Now it is private because you are not mentioned private over here. Then we have public members over here. So int B is one public member, and then we have two functions, get val, which is not going to return anything. We are not passing any values to it either. And the other function is int get underscore A, to which again we are not passing any parameters. Then we have our derived class addition. Okay, then colon, visibility mode is public, and we are going to inherit the class maths. So in class addition we are introducing one private variable, that is int C, and then under public we have two more functions, add and display. Both are again not returning any value, or we are not going to pass any parameters to these two functions. Now when this declaration is done, we are inheriting these members also. So A will be inherited in class addition. Now we are going to write the definition for get val function. So notice that we are writing it as maths colon colon get val. So this is the definition of get val function, and we are just going to initialize values of variable A and B to 10 and 15 respectively. So just to notice again here, this is your private member and this is your public member. Now we are writing another definition get A, which is just going to return me value of A. Okay, so assuming this we have set the value as 10, so it will return me 10. Now important thing is we are going to write the definition for add function, which belongs to your class addition. I have this variable C which I have declared in the class addition, so I'm using it as is. Then we have one function get underscore A, which belongs to your original class maths. Okay, now we are not writing any object over here because this is directly accessible because we have done the inheritance. Okay, then we are writing plus B. So again B belongs to your class maths, which is of type public. So here it will still have scope as public. And then we have third function, that is display, which belongs to addition. So here we are writing A equal to get underscore A, which is this function, which is just going to return as value of A. So whatever the current value that your object is going to hold, that will be returned over here. Okay, Then we are just simply printing B and C. So let us see what happens inside of main function. So we have created object a1 of type class addition. Okay, then I'm calling a1 dot get val function, so which is this function. Okay, so this is going to set value 10 and 15 to a and b respectively, and then we are going to call add function, which belongs to your class addition. Okay, so what is going to happen over here? It is going to return me value of a. We are not directly using a. The reason is it is a private member, so we are going to use it via public member. So here I am going to have value as 10 plus b. Now b is directly accessible because it was public member, so value of b is 15. So C is going to have value stored as 25. Now the compiler is going to call a1.display, which is this function. So it is just going to display value of a, b, and c. So again, I'm writing get underscore a over here because a is not accessible directly because it is a private member. This particular code will print a equal to 10, on the next line b equal to 15, and on the next line c is equal to 25. After that, we are just doing few more things. I am updating value of b with the help of object a1. So a1 dot b equal to 20. What I'm doing is I am overwriting value of b with 20. Just notice that b belongs to your class maths. Okay, but because we have inherited this class, so these members are accessible to my object of type addition. So on the next line, I'm writing a1 dot add. So again, this function will be called. So we know that value has been updated. So value of a is still 10. So 10 plus updated value is 20. So c will become 30. So this is the new value of c. And again, we are calling the same function, that is display. So it is just going to print uh, new values of a, b, and c, which is 10, 20, and 30. Okay, and after that my main program is going to end. So here is the output. So once this call is made, this part will be printed, and when we have updated value of 20, so once this call is made, this part will be printed. So this was single inheritance, which was very easy to understand. Now let us move on to the multi-level inheritance. In multi-level inheritance, for the example we have, for this example we have created class vehicle, and we have protected data member, and it is of type int. We are calling it as int underscore id, and then we have our public members. So int b is a public integer, and then we have two functions, get id and put id. So to get id we are passing one integer, and put id is returning us one integer. So we are just going to assume this as our base class, and I'm going to define my function get id, which belongs to vehicle, so to which I'm passing one integer variable a, and I'm just going to set that value into our protected data member of type integer int underscore id. And then the other function put id, it is just going to print the value of int underscore id. Because this is a protected member, it is treated as private, hence it cannot be directly called via an object, but it can be utilized, or it can be called using one member function. In this case we are using get id and put id. So because public data members has access to protected members. So then we have our derived class car. So this is d derived class. So our visibility mode is public, so everything will remain as is. So protected variable will be inherited over here, and those will still remain as protected. So class name of the derived class is vehicle. We are adding one more protected data member into derived class, that is of type float, calling it as version. And then we have two more functions over here which are of type public. The functions are get version and put version. So get version is receiving one value of type float. So when we define the derived class get version, which belongs to class car, I'm passing variable float a to it, and inside of this definition I am storing value of a into variable version, which is protected. It is accessible here because protected members are accessible to your public member functions. Similarly, put version is going to just print this value. So this is the function definition of function put underscore version, which belongs to your class car. And then we have one more derived class d. I'm writing here just for the reference. So show is your derived class which is inheriting class par under visibility board public. So here we have another variable. This is private because I have not mentioned over anything here. So inside of public scope we have display function which is not returning or receiving any value. So what is happening in this program is we have one base class vehicle, okay, and then it is being inherited to the class car, and then car is being inherited by new class show, okay. So all the members of variable will be related to car, and all the members from vehicle and car via class car will be inherited to your class show, okay. So this is multi-level inheritance. Now let us check what happens when we write the main function. I forgot to mention one more function that we have declared over here, display. So here is the definition for the display function. It is just calling these two functions which belong to your class car, okay. So it is just calling them directly. A reason that it is able to call because these are public type of member functions, and because there's an inheritance from car to show, these functions are accessible. So inside of main function I am declaring s1 as the object of class show. So when I'm writing s1 dot get id and when I'm passing value as 1, so this function will be called and value of int id will be set as 1, okay. And then in the next line when I'm calling s1 dot get version, passing 1.3 as the value, so this function will be called. So because 1.3 is being passed, so this value will be stored inside of version variable, so version will become 1.3. And then on the next line we are calling display function, which is this one. So internally this function is calling put underscore id and put underscore version. So if you check definition over here, so put id is going to print vehicle id, and then it is going to print int underscore id, that is 1, and then put version is going to print car version colon and then value of variable version, that is 1.3. So output of this program is this, okay, fairly simple to understand. So this is your pictorial presentation what is happening here, okay. So once you understand this, so it is just matter of minutes to understand what exactly is happening over here. So whenever the inheritance is being made between these two classes, that is your base class and derived class, so all the members will be inherited to the next class. So once the multi-level inheritance is done, we are moving on to multiple inheritance, okay. So I'm just trying to simplify things over here. So I have renamed, or I'm using class name as a, b and c over here. So if you notice, we have one protected member, that is int a, and then we have public function get underscore int, to which we are passing one integer, okay. Then we have another class b which also has one protected member, that is b, and it has a similar function to a class B, but it is get underscore, to which again we are passing one integer. Okay, so we have class A and B. Okay, then we have class C. Now it is inheriting two classes, A and B at the same time. Notice that we have used comma operator over here, and for the both classes the visibility mode is public. Okay, so what is happening here is, so this is your derived class, so A and B are being inherited to C. So inside class definition of C we have just public scope, and inside it is only single function display, which is not returning any value or not accepting any values, or we are not passing any values to it. And then we are defining our both functions. So get A, which belongs to A, I'm just passing one value x to it, and x has been assigned to A. Similarly, in function get underscore B, which belongs to your class B, I'm passing integer value y, and which is being stored into variable B. Now important thing is here, so we are writing definition for display function which belongs to C, that is your class here, that is a derived class. So technically these two are becoming here your base classes. Okay, because the inheritance is done now, so what is happening over here is A and B is directly accessible to your class C. So hence data member function display is able to access variable A and B directly. Okay, because the visibility mode was public, so protected members is still going to remain protected in the class C. So just one additional step that we're doing is we are writing C equal to A plus B. So we're just writing addition of variables A and B. So inside your main function, when I create one object C1 of type class C, so I am able to call this function C1 dot get underscore A. I'm passing it the value as 15, so that value will be stored over here. So A will become 15, and also I'm calling function get underscore B, passing value as 16 to it. So B will become 16, and finally I'm calling function C1 dot display. So this part will be executed and it will display A equal to 15, B equal to 16, and C equal to addition of these two numbers, that is 31, and then your program will end. So this is output of this program. So multiple inheritance we have completed. Now we will move on to hierarchical inheritance. In case of hierarchical inheritance, what we have done is we have created one class calling it as maths. Then we have two integer variable with the scope as public, and then we have one function to which we are passing two integer values, calling this function as get underscore val. Then I'm writing definition for this same function get underscore val, to which I'm passing integer x and y. So once these values are passed, I'm just storing those value into A and B respectively. Then I'm writing two more classes, one is addition and other one is multiplication. Both are inheriting class maths with the visibility mode as public. So you can check here, maths and visibility mode public. They both have one function add and mul, that is multiplication respectively, and it is just going to perform addition operation on variables A and B. Now notice that A and B are again directly accessible because we have inherited these values from class maths. So what is happening is maths is your base class, okay, and then it is being inherited into your other class, that is addition, okay, which is your derived class, okay, and then we have one more inheritance, that is for your class multiplication. Okay, so this is hierarchical inheritance that is being performed because of these two type of classes definition that we have wrote here. So similar to add function, we have mul function where we are just performing multiplication. Okay, now inside of your main function we have created object of type class addition, and we are calling it as a1, and other object m1 which is of type class multiplication. So using object a1 we are calling function get underscore val, to which we are passing values at, and then we are performing operation add. Okay, so when this 15 and 16 as values are passed via your function get underscore val, so what is happening is values of a and b, which somehow now relate, which are now associated with your object a1. So a1 dot a becomes 15 and a1 dot b becomes 16. So once this add function is called, it is just going to execute this particular lines, and it is going to print a plus b is equal to addition of a and b. So a and b is 15 and 16, so we are going to get over here a plus b equal to 31. And then on the next line we have m1 dot get underscore val. Again we are passing 15 and 16 as values to it. So again this particular function will be called, and values of a and b will be updated with 15 and 16. But now notice that earlier we have called a1 dot a and a1 dot b. Here we are talking about a1 dot a 15, and we're talking about m1 dot a equal to 15 and m1 dot b equal to 16. So m1 and a1 are holding different set of values a and b. Now once this initialization is done using function get underscore val, I am just calling m1 dot mul, so which is just going to print a multiplication value of a star b. Okay, and after that the program will end. So output of this program is this. So a plus b is 31 and a multiplied by b is equal to 240. So this was hierarchical inheritance, and now we are going to learn about hybrid inheritance. So we have our class maths with public data member as int a. Then we have a derived class. Then we have a derived class b, which is inheriting maths with visibility mode public. And we have one public function calling it as b. We are just assigning value 20 to variable a. Now a is directly accessible because it's a state inheritance. I'm uh, inheriting public members int a with visibility mode a. So a would be directly accessible to me, and whenever an object of class b is created, variable a will also be created. Okay, now we have one more class, that is class c. Okay, it has a separate variable b which belongs to the class c, and then we have one function c which is initializing value of b to 10. And after that we have one more class sum, which is inheriting two different classes b and c with visibility mode as public, and it has one function called as sum, which is going to display me value of a and b. Now let us try to understand this via one diagram, because we are talking about four classes over here. So initially we had our class maths, okay, which is your base class. Then class b is inheriting class maths. Okay, so I'm writing b over here. So this inheritance is done. Then we have one independent class c, okay, which is technically a base class again. Okay, so this is your base class, this is your base class, this is a derived class, and even your class sum is a derived class. So why? Because sum is inheriting two classes b and c. Okay, if you check here, sum is inheriting b and c. Okay, so this is the type of inheriting that is happening over here. Okay, so maths being your base class, b is inheriting it, and c is another base class which sum is inheriting along with the your existing derived class b. Okay, so this type of inheritance is a hybrid because we are using multiple as well as multi-level inheritance in it. Now because this is done, so when I'm saying a and b which belongs to class c and a, okay, so class c has b and class maths has a. So if you just check, a and b are still going to accessible in class sum. Okay, so that is why when I create object s1 of type sum, so s1 dot sum can directly be called because this function is part of your class sum, so there's no any problem. but inside of function sum I am referring a and b directly because those are inherited now, so we can use them directly. Now whenever a class object is created, these functions will be called automatically. Why? Because these are constructor. If you check the class name and function name over here, so these are constructions, same name, so hence this will be called by default. Okay, so when this line is executed, so some s1 will be executed, so s1's constructors will be called. But because these values are relying on its base class, so these constructors will also be called. You might have a question that which constructor will be called first. So obviously the constructor of your base class will be called first, and then constructor of your derived class will be called. So once this declaration is done, uh, because we have done inheritance here of b and c, so this constructor will be called first, so value of a will become 20. Then this constructor will be called, so value of b will become 10, and after that this constructor will be called. So sum will be equal to a plus b, that is 20 and 10, so 20 plus 10 is equal to 30. So this constructor is, sorry, there's one more important point to notice over here, that this is not a constructor, this is just a member function. Because if you just notice, this s is in caps and this s is in small. Okay, so this is not a constructor, this is a normal function. That is why we have called it as s1 dot sum sum in small. So this is a normal member function. Okay, but anyways, the point that I'm trying to make over here is that though I have created object of s1 over here, the constructor of your base class are called automatically. Okay, so output of this program is sum equal to 30. Okay, now one important point that I want to make over here is, let's say you extend this as well. Okay, so let us assume that your class C is also inheriting class maths. Now the problem here is that A will be inherited here as well. Okay, so A will come here, and because of this inheritance A will come here as well. Now when this multiple inheritance will be done for your class C, whenever one object is instantiated, you will have two different version of variable A. So for a compiler, this is one ambiguity. Okay, now to tackle this, there's a provision in C++, and we call it as virtual base class. Okay, so what happens in virtual base class is you have your class math, then two public data members a and b, and we have one function which is just going to print value of a and b. Then you have a class b, and I'm writing virtual public math. So math being my base class, I give access to the new derived class B to make it a virtual base class. Okay, so class B becomes your virtual base class. So syntax is virtual keyword that you can add either before public or after keyword public. So you can write virtual public math or you can write public virtual math. So both are allowed in C++. Now inside a public scope, we are writing get underscore a as a function to which I'm passing one integer variable, and I'm just going to update value of a. Okay, so which technically belongs to your class math. And then we have another class, class C. Again, I'm mentioning word virtual, so virtual public math. So this also becomes your virtual base class. It just has one function get underscore b to which we are passing integer value y, and y is being stored into b. B is directly accessible over here because of this inheritance. Okay, so after doing this, what is happening here is we have this base class math. Okay, then we have done the inheritance to b and inheritance to c, but because we have added this keyword virtual now, so these two also become your virtual base class. Okay, now if you just notice over here, class D, I am just doing the inheritance with class B and class C. So this is my new class D. Okay, so this is my multiple inheritance. Okay, Now, because the variables are coming via these two modes over here, so in the previous case, it would have given an ambiguity to the compiler. All right. So because we have made B and C as the virtual class, you can completely ignore this part just for the time's sake. So you can just assume that these are two different variables over here. These are two different classes over here. So to the compiler, it becomes a virtual class, and it is just going to assume a single copy of the common variables. So inside of main function, what is happening is we have created one object d1 of type class d. So d1 dot get underscore a, it will initialize value of your variable a to 10. Similarly, the next line will initialize value of b to 20. And then we are just calling function show, which belongs to your class math, and it is just going to print value of a and b, which is 10 and 20, and after that your program will end. So things to notice over here is that a and b, though it belonged to uh, class math, and because this math was inherited by both variables b and c, and B and C, which are still extended or which have got inherited to variable D, no duplicate copies are made over here, only single copy is retained, because B and C are treated as virtual base classes over here. So very important topic, virtual base classes. So pointers is a very important topic in C++. We know that pointers are derived in a type that referred to another data variable. Okay, so pointers we have seen in C language in detail. We are just going to revise pointers, and we are going to see how pointers are used in C++. So again, pointers are by definition nothing but derived data types which refer to another data or a variable. Okay, and they do that by storing variables memory address location. Okay, they do not store data as such. So just to understand this concept here, assuming this is a memory location, assume that it has certain address over here, and this memory is allocated to variable x. We have suppose initialized value as 10 and stored it into x, so 10 is here. Okay, so x has stored value 10 at address location this. So when I say a pointer, so pointer is another variable which basically points to this location. So what is location? So this is the location address. So this particular information is stored over here. Okay, so pointer variables, they do not store actual data, but they just store address location of another variable. So fairly simple concept to understand. Then the syntax of declaring a pointer variable is like this. So we have our data type, then star as the character symbol, then your pointer variable name. Okay, so for example, you can have your integer data type, then star p. Okay, so p is the pointer variable. Now that is denoted by star. So this is syntax for our integer pointer. Similarly, we can have a character pointer. We can use character data type, then star, and then your character pointer name. So let's say chp is my character pointer name. So we are going to take one example how the pointers can be work when you have multiple variables and then a pointer variables pointing to those certain variables. So in this example, we have one integer pointer, that is a, and then a normal variable b of type integer. So I'm initializing b with value 10. Okay, so what is happening here is we have a variable, a certain memory is allocated to it. Let us say ox1 is the memory location for variable b, and then we are initializing value of b with 10. Then on the next line, I'm printing address of b. So this is just a string that will be printed, and then I'm saying address of b, ampersand b. So this line is going to print this information. And then on the next line, we are printing value of b. We are simply providing b. So on the next line, b will be printed. with this string. So value of b inside bracket b colon, then value of b, that is 10. And then I'm initializing my pointer variable over here with address of variable b. So variable a will be pointing to address of b. So ox1 will be stored over here. So after this line, what I'm doing is I'm printing address of b in pointer a, and then I'm simply writing a. So this information will be printed, and then in the next line I'm writing content of b in pointer variable a, that is star a. Now I have given this trick multiple times in our C programming language series as well. To understand star a, we can just simply replace it with star ampersand b. Why b? Because of this particular statement, because a is pointing to address location of b. Now to read this value, we just simply replace star with keyword value. So value at address of b. So this is our address of b, and what is value over here? That is 10. So star a is going to print 10. Okay, so this line will print value of b using your pointer variable a. Then on the next line, I am reinitializing b with 20. So this particular line is going to print address of b in pointer a colon a. This is again going to print this value. And then on the next line, we are again printing star a. So that is nothing but value at address of b, so which is updated value, that is 20. Now another way to update value of b is by using your pointer variable. Okay, so star a equal to 30. So this is nothing but writing value at the address location of b equal to 30. So this value will be updated to 30. So we have seen initially the value of b was 10, then we re-updated it to 20, and then using your pointer variable we re-updated it to 30. After that, this line is again going to print address location of b, and when we just simply print b, it will print 30. Reason is that the value of b was updated by variable a. So this will be the output of this program. So this was output that we compiled on a local computer, and this was the address location of variable b. So this was initial value of variable b, that is 10. Then it got re-updated by this statement, so it printed us 20, and then using pointer variable we re-updated the value and it got re-updated to 30. And wherever we had printed address location of b, that was unchanged throughout the program, because we technically did not change or did not touch anything related to the address of b. Now we can perform arithmetic operations as well using pointers. For that, what I am doing here is I have created one integer array of size 5, and I have set initial values to all those array locations. So these are integer values that will be stored into arrays 0th location, 1st location, 2nd, 3rd and 4th location. And then we have one integer pointer here which we will be using to point to our array, and then a variable sum will be used to add up all these numbers and store output into variable sum. So on the next line, what I'm doing is I'm initializing, or I'm pointing my integer array to my pointer which is of type int. So ptr is going to point to the first location of the array, so that is 0th location. So after that I'm creating one for loop, so starting from 0 till 4 it will loop through, and at every iteration this is going to get executed. So in the first statement we are printing address of variable I, so that is our index variable or the loop variable. So in the first iteration it is 0, so 0 will be printed over here, and then we are writing equal to ptr. So ptr, because it's a pointer and it is initially pointing to this first location, so it will display address of this particular array element. And on the next line we are displaying value of variable I is equal to star ptr. So again, star ptr is nothing but your value at address location of this variable. Okay, so whatever the value is here, which is 10, so 10 will be printed. And once that happens, we are updating variable sum with sum equal to sum plus ptr. So in this particular iteration, value of ptr is 10, so 10 will be added into sum. So in the first iteration, 0 plus 10, that is 10, that will be stored into sum. And then last line is we are writing ptr plus plus. So this is very important line over here. So here what is going to happen, we are increasing pointer by 1. So wherever the pointer is pointing correctly, that pointing location will be incremented by 1. So pointer will start pointing to the next location in the array. So once these set of statements are executed, pointer will be incremented by 1, and in the second iteration, value of I will be incremented because of this statement I plus plus. So I will become 1, and then in the next iteration, address value of new variable I. So address of your pointer variable, that is for the first index, will be printed here, and then the actual value which is stored at that particular location will be printed, and again your sum will be updated. So in the second iteration, what is going to happen, 10 plus 20. So 20 is your current value where your pointer is pointing, and sum was your previous value which was updated after end of your first iteration. So sum will become 10 plus 20, that is 30, and again pointer will be incremented, so it will point to this location. So similarly, your these variables will get added into variable sum. In the final iteration, when your I becomes 4, this is going to happen. So let us assume that 10 plus 20 plus 30 plus 40 has happened now. So this addition was stored into variable sum. So new value, that is 50, will be added into existing value of sum, that is 100. So 100 plus 50, so it is 150. So sum will be finally updated to 150, and again your pointer will be incremented. But now what is going to happen, that we have already ended the added limit over here. So it doesn't matter where the pointer is going to point next. So obviously pointer is going to point to some garbage location which could be irrelevant for us, and the program will terminate because value of I will be incremented from 4 to 5, and this condition will be false. So next iteration will not be executed, so that will effectively end your for loop, and this line will be executed. So cout is going to print sum of array is equal to 150. So in this program, what we have done is, using pointer variable, we have traversed through all the array elements of one integer array. So this is how we can perform arithmetic operations using your pointer variables. So this is going to be the output of the program. So program has printed all the addresses of your array elements and value which are stored at those address locations, and in the end it has printed the sum as well. Now in the next slide we are going to talk about array of pointers. Okay, like we have array of variables, we can also have arrays of pointer variables. So this is one integer array, and then we have one integer pointer array. Okay, so like we have 5 variables over here which are basically combined into one array, we can have 5 pointers which are combined into array. So what we are doing here is, we are using these pointer variables to point to all these normal variables or normal integer variables, and each pointer is going to point to this address locations. Okay, so in the memory what is happening, we have these 5 array elements. So let's say 10, 20, 30, 40, 50, and then we have integer pointers as well. So these are 5 integer pointers. Each of that is going to point to these address locations like this. but this doesn't happen automatically. So for that we are using this for loop. So my for loop is going to iterate from 0 to 4, and then one by one each pointer variable will start pointing to my integer, which is part of your array. So in the first iteration, my 0th location pointer variable will start pointing here, and similarly, other variables, other pointer variables will start pointing to the other variables. So once this pointing is done, in the next loop we are going to just reprint all these values, which are 10, 20, 30, 40 and 50, using our pointer variable. So this is my for loop starting from 0 to 4, so 5 address locations, and we're just printing value of integer array. Here I'm passing integer I, which is going to display index value of my array, then equal to, on the next line I'm writing star ptr I. So what is technically happening over here? In the first iteration I'm writing star ptr I. So this is my ptr, okay, and this is my integer array, okay. So I'm writing address location of integer array 0, okay. So value at the address of integer array 0, which is 10 for the 0th iteration. So that will be printed. Similarly, in the second iteration where I becomes 1, 20 will be printed, and so on. In the last iteration 50 will be printed. So this is the output of this program, okay. So these are your normal integer array, okay. These are your index x, and all these values are printed using array of pointers. Now we are going to touch upon strings, okay. So strings are nothing but your character arrays, okay. So if you check this particular string kodegod, so it is nothing but character set of 7 characters, and as we know that every string ends with 1/0, which basically denotes compiler that this is end of the particular string. So this is nothing but 7 plus 1, that is equal to 8. So this particular string str is of size 8, and then we have one character pointer variable, that is star ptr. So I'm just going to write ptr is equal to str. So when you write a string array variable without square brackets, so this denotes address location of the first character variable, that is this value. So that I'm assigning to my pointer variable. So because of this statement, your pointer variable ptr has started pointing to this first location, okay. So ptr is pointing to the first character location of string str, okay. Now once this pointing is done, using variable ptr we can print this string as is. So while printing this string we can simply write ptr. So because ptr now denotes this address location, so we can write ptr and it will print value of string in variable ptr is this value. So because it is pointing this particular location, it will start printing kodegod till the compiler reaches /0. So once /0 is reached, it will, for compiler it is end of the string, so it will stop printing there, but it will print kodegod completely. Now in the next line what I'm doing is using the for loop and our standard notation that we have seen in the previous video, and using the standard notation that we have seen in the previous video, that is star ptr, we can still use the traditional method, and along with star ptr plus plus we can increment each location using your for loop, and we can still print one character at a time, okay. So using for loop, using this particular for loop, which is going to iterate through 0 to 7, it will print output like this. So because of this particular statement, the compiler is going to print this particular line, and it is going to print kodegod as complete string, and then using for loop these values will be printed one by one as a character. So fairly simple concept to understand, and in the next slide we are going to talk about pointers to objects. So like a pointer variable can point to a normal variable, we can also have a pointer to object which can technically point to another object. We can have a class pointer which can point to object of a class. So in this example we have a class, I'm calling this class as math, then we have private scope, and then three variables a, b, c, all of them are of type integer, and then in the public section we have one function math which is your constructor. If you check, the class name is same as the function name, so this is your constructor and it is default constructor which has these initialized values, or it is a parameterized constructor to which we have passed these values, and those values are stored into your data members a, b, and c. And then we have one more member function as addition, which is just going to simply return addition of variable a, b, and c. And then in the main function I have created two objects m1 and m2 which I have passed these values. So these values will be overwritten with this set because I'm explicitly sending those values. So these initial values 10, 20, and 30 will not be used actually because I'm explicitly sending fresh set of values when I'm creating this object m1. And then we have one class pointer. So star ptr math is a pointer to object. Then what I'm doing is I'm pointing ptr math, which is my pointer to object, and I'm referring address location of my first object m1. Okay, so inside of memory when m1 is created, okay, let us assume that abc for object m1 have got these consecutive spaces, and we have, because initialized values 30, 12, and 15 to these address locations, and because of this statement I have created one pointer which is going to point to my m1. Now once that pointing is done, using my pointer variable I can access these data members. Also I can access my member functions too. So we can use array operator over here. So using the pointer variable I'm calling my member function directly. Okay, so this statement is similar to writing m1 dot addition. Okay, so output of this statement and this statement is same. Only thing is that we are using pointers here to call my member function. Then what I'm doing is for m2 object where these set of values were created initially 5, 60, and 20, so I'm changing pointing of my pointer object from here to here. So this will be broken and new pointing will be created over here. So when I'm writing ptr math along with array operator and then addition, so addition function will be called over here, but this time it will be referring to these values. Okay, because m2 has a different set, m1 has its own different set. So depending on choice that we make and where the pointer variable is currently pointing, those set of values will be accessed. Okay, I think it's fairly easy to understand this concept. uh, so let's move on to the next slide. So this will be the output of this program. So 57 is outcome of addition of variables from m1 object, and 85 is the output of addition from my variables in m2. Now one very important uh, pointer that C++ has, it's this pointer. So why there's a need of this pointer? Okay, so whenever a data member is called, so sometimes there could be a case wherein we need to understand that which particular object I'm referring to. Okay, so my program can have multiple objects. Okay, And for a class, when a data function is called, okay, so when compiler loses its scope, let's say compiler is now executing some code from the class, okay, so this particular function can be called from other objects too. So while we are executing these lines, it's good to know that which particular object we are dealing with currently. So in that case, because each object could be having different names like M2, M3 and M4, we cannot refer those over here, okay. That is why to refer to your existing object, this pointer can be used. So this pointer is a keyword. So this is the keyword which basically points directly to the called object, okay, as in the object which is calling your function. This object will be automatically pointing to that object, okay. So let us try to understand this by with the help of one example. So again, I have class math, then we have two private variable a and b, and inside public section we have math as the constructor, wherein we have few default values x equal to 15 and y equal to 20, and which are being assigned to variable a and b, which are again the private members. And then we have one function addition, wherein we are adding two values and returning total of those two variables. And then we have another method compare, to which we are passing object math. So when this particular object is passed, inside of this function I'm referring this arrow operator addition. So whenever I'm going to make this call, the object which is calling this method, data members of that particular object will be used for executing this particular function, okay. So inside this particular function, what is happening, using this operator, I'm using object which has called this particular function, and then I'm comparing whatever the value that this function is returning me with my fixed object which I'm passing here, okay. So this addition function is going to return me addition of two different objects, okay. So let us try to understand this by our main function. So we have two objects m1 and m2, to which I'm passing values 560, 30 and 12 respectively. So in the memory, what is going to happen is, so this is my m1, to which 5 and 60 is initialized for a and b, and then m2, again here a and b is initialized with 30 and 12, okay. This 30 and 12 will be passed to the constructor, and constructor will initialize value of a and b. So this is something that is going to happen. And then interesting part, inside of if, I'm writing m1 dot compare. So this particular function will be called, but notice that I'm calling compare function using m1 operator. So when here we send this, so technically we are calling m1 dot addition, okay. So because compare function was called by m1, hence this is pointing to m1. So m1 dot addition is performed here. So this particular function call is going to return me addition of 5 and 60, that is 65, and 65 will be compared with math. So inside this particular statement, I'm passing m2 as well. So m2 is passed over here as a copy. So we are going to compare it with m2 dot addition, okay. So this particular function here is going to return me addition of 30 and 12. So that is nothing but 42. So we have the results here. So 65 greater than 42, which is a true condition. So true will be returned over here. So if true, which is a true, so C out m1 is greater than m2 will be printed, and this particular code block will be skipped. So output of this program is m1 is greater than m2.
So important concept that we have learned over here is about this pointer. So this pointer is fairly commonly used across object-oriented programming. So this concept is almost similar everywhere. And finally, in the video, we have one important topic, that is virtual functions. So when we use same function name in both base class and derived class, then the function in base class is declared as virtual. So we have seen in inheritance, there could be cases wherein we may require certain functions to be inherited, but your base class need not have certain definition. So in a way, when you have some base class, you can just have certain declarations done, but once the inheritance is done, you can have your definitions inside your derived classes. Okay, but let's try to understand this with one example. Before that, we just let us check how the syntax can be implemented for virtual functions. So keyword virtual is used just before your function declaration or definitions. So virtual, then you return data type, then your function name, and then your list of parameters. So here is one example on virtual functions. So class parent is my base class. So here I'm adding keyword virtual, just notice that, and then I'm writing this is the base class. Then we have child, which is inheriting my parent. So inside of my class definition of class child, I have similar function name, that is show. Notice we have not write virtual over here, and I'm writing this is the derived class. So parent star p, I'm creating one pointer variable for my class parent, and then a normal object for class child. Then I'm writing p is equal to address of c. So what is happening over here is I'm creating one pointer variable which is pointing to object of my derived class. So once this pointing is done, using arrow operator, I can call show method. But because this pointer variable is pointing to my object of derived class, so this particular function is called. Okay, so output of this program is this is derived class because this particular code is called here. Okay, now again let us try to understand this with one more concept, that is about pure virtual functions. So as I explained in the first slide related to virtual functions, there could be cases wherein you can implement your base classes, but certain functions need not have definitions inside your base classes. So in such cases, what you can do is write pure virtual functions which technically do not have any definitions, but they can have certain declarations. Okay, and that can be denoted something like this, equal to 0 semicolon. So pure virtual functions are usually called as do nothing functions as well. So they do not have any definitions inside of your base classes. So here is one example for the same. So this is class shape, and inside of public section we have our virtual function which is returning variable of type float, and then this is your function name calculate area, to which one float variable is passed, and because of this equal to 0 we can say that it's a pure virtual function. Then we have class square, which is a derived class, and we are inheriting shape over here as the class, and we are writing definition for our function calculate area. Okay, so this is the definition. And then we have another class, that is circle. So here we are inheriting shape as a class again, and we are redefining the same function calculate area. Okay, so just to denote here, so shape is my base class and it is being inherited into two more classes. One is square and other one is circle. So your base class was carrying this pure virtual function, okay, and those have been redefined into these two classes. So when I'm creating object for both my derived classes, so when I make a call using their respective objects, their respective functions will be called. Okay, so when I say s, which is object of square, that is s dot calculate area 6, so this function will be called. So it will do 6 multiplied by 6, it will return me 36 for this statement. So it will print area of square is equal to 36, and then on the next line I'm writing c dot calculate area and then 7. So c is object of class circle, so c dot calculate area. So this function is basically referring here. So this code will be executed. So this will calculate 3.14 multiplied by 7 multiplied by 7. So whatever that calculation is, it will be returned over here and it will print area of circle and then the output. So output of this program is this.
We are going to learn about how to operate on files. We are going to learn how we can open files, how we can add content to the file. So goal is to learn about how basic read and writing operations can be performed on files. So let us begin. So before we begin with the how actual operations can be performed on files, let us understand how input and output can be processed when we do file operations. So we can use insertion operator. Let us say this is your standard input device over here. So whatever the input that we can provide to your program, so that program can store that information into internal memory, let's say resistance memory or your RAM, and that information is then passed to stored into files. So your files can be stored into external memory, that could be your internal hard drive, external hard drive, or magnetic tape, etc. Similarly, you can use these memories to access those files in order to read data from those files. So you can use these files and read the data, and eventually this data can be passed to your programs, and the processed information or the processed data can be sent to the output devices or display units or the printers using cout or extraction operators. So this is how interaction can be done with the files using your programs. Now let us take one more step. We'll understand how file input and output stream helps us doing this. So your program can output data using output stream. Okay, output stream can be used to write data to your files. Similarly, data files can be read and input stream will be used to provide input to your programs. Okay, so this is somehow a circular system. Okay, and input stream and output stream can be used to process information over here. Now, next is how classes related to file stream operations can be used. So we have our iOS as the main class, okay, and stream buffer is a pointer that is used for processing input output information, and that again extends to your file buffer. Then we have base classes iStream and OStream, which are extended and derived into ifstream and ofstream. Okay, so these are input file stream and output file stream. Okay, similarly we have fstream base class, and which gets extended to fstream. So we don't need to get into too much of details over here. Just last point that I missed is iStream and OStream gets further extended into iOStream. Okay, so this is just basic details that you need to understand, but when you write programs, I think these level of details are really not required for you to be aware of, but it's still good to have knowledge of this. Now next one is a program wherein we can understand how we can work with the single file. So in the main function I'm writing ofstream, and fout is the object over here. Then I have a string line, so I'm using fout dot open, and then I'm providing the file name over here. Now because there is no path written over here, so this will be the file that compiler is going to search on the same folder or at the same path where your this whole program is residing. Okay, in case you're using, let's say, Windows system, so let's say c colon, let's say, working underscore dir is your directory, and inside that you're writing your program, let's say files dot cpp, then this code.txt needs to be at this location only. Okay, otherwise compiler won't be able to find that file and it will give an error. So this was in general about the file structure. Okay, so in case file does not exist in that particular location and you still write open command, so depending on the mode, compiler can create that file if it does not exist. Okay, and in case you have a strict mode where the compiler will give an error in case the file does not exist. So you have to specifically check whether the file is existing or not. If it exists, you can open it directly. If it does not exist, ideally you should create that file. So in our case, we are just opening this file. Okay, and then I write cout this path, and I'm writing while f out get line cin comma line. So whatever the input that we are going to read from the input device, that is keyboard in this case, that will be stored into your string line. And then if line is equal to -1, that is in case there is nothing in that line, we are writing break. So if your line is empty, so this while loop will be exited with the help of this break statement. And in case this condition is false, so we are just going to write f out extraction operator line extraction operator endl. So whatever input that we are getting from our standard input device, that will be inserted into your file. Okay, so this is what is happening here. And once this loop ends, we are writing f close, so that is this file will be closed after that. And we have written the code into our file, and now we are going to read from that file. So I'm using if stream input file stream, so I'm creating an object f in here. So again, I'm writing fin open, I'm going to open the same file, and then I'm writing text in the file, so this will be printed on the output screen. And I'm writing while fin, as long as fin has some content, I'm going to read content from that file, that is get line. I'm using this file, and then the content that I'm reading currently, that is single line, that will be stored into my variable line, that is my string variable, and that content I'm going to print over here. So as long as I don't reach to the end of the file, as long as there's some content in the line that I'm reading, so this loop is going to continue. Okay, and once this process is completed, I'm just going to close that file. It's very important to remember that when you open a certain file, or when a program opens a certain file, we must always close that file. So in case you open a file with, let's say, variable x, and you don't close that file, and let's assume that another variable y or file pointer is trying to open that same file, the compiler will give an error because the file is already being used by some other process. So that will give you an error. So it's always a good practice to close your files processing is done, or when you think that your job is done. So fairly simple to understand this concept, and this is how we work with the single file. So here is the output of this program, assuming the file was having this content. So kodegod, it is something that the file has printed. So this is your output. This is the part wherein input was given as kodegod, and then we entered -1 as the text over here. So this was your first line, this was your second line. So -1 is the part of the file, but just because you have written -1 over here, we are just going to compare over here. So you can write anything instead of -1. Okay, so this was just to help you understand how the program can be performed. There are other ways to identify how whether the end of the file is reached or not. So you can use EOF as the keyword, or there are additional functions provided by C++ library. That is something that we are going to check in the upcoming slides. Now next is working with multiple files. So here we are. We have one constant integer, initializing it with 100, and I'm using n as the variable name. And then I have a character string, or I have character array, which is forming a string, calling this character array as line, and it is initialized with 100 because n is 100. Then I'm using OF stream and creating object f out. So then again, I'm opening code.txt file. Okay, I'm just writing kodegod here. This will be inserted into code.txt file, and I'm closing that file. Okay, so once this file is open, I am writing kodegod into it. Then I'm opening another file with the same object. Okay, this time the file name is kodegod.txt. Earlier one was code.txt. In the second file, I'm writing kodegod.com. Notice that I have written only kodegod in the first file. Then I'm closing that file again. So here I'm opening one file, writing some content to it. Here I'm opening another file, writing some content to it. Then I'm using ifstream class, creating object as fin. Then I'm using fin. I'm opening first file here with the open function, and I'm writing text in the file code.txt. So this will be printed on the output screen. And then I'm writing file loop. So while fin.getLine, here I'm writing variable line as the character array to which number of characters to be read is specified. And then I'm just printing that file output. So here what is going to happen is that, a line character width of 100 is used to read a line from that file. So again here, one by one we are going to write, as long as getLine does not return null value to this function, so this will keep on working. Okay, so as long as this variable is not becoming null, so this will continue. And once this operation is performed, I am just closing that file again. Similarly, I'm executing same code for the same file. I'm opening, reading all the lines from the file, and printing it on the output device, and finally closing that file. So this is how we can work with multiple files. You can have multiple output stream variables, you can have multiple input stream variables as well, or you can use same variables as long as you're working on a single file at a time. So this is the output for the program. In the first file you wrote this content, same content was written on the output devices, and same goes with the file number 2. Now, as I mentioned in the one of the previous slide, that how we can detect end of file is reached. So what we can do is, with your input file object, you can write EOF function. So as long as that function is not equal to 0, your fin object has some content. So when your fin object dot EOF not equal to 0, if this condition is true, then you can exit the code. So this is exit 1 here. So this is standard library function. You can ask compiler to terminate the program when a certain condition is met. So EF is a member function of your iOS class, and it returns a non-zero value if end of file is detected. Now let us continue, and we are going to understand how we can read from two files simultaneously. So, but additional point to check here, that we are going to use EOF function over here. So again, these are two similar variables. N is equal to 100, it's a constant variable, and I have a character array line of size 100 because N is 100. I have two input file stream objects, fin1 and fin2. I'm opening two files at the same time, one under fin1 and other one under fin2. Then I'm writing this particular code, I equal to 1 and I less than equal to 5. Inside of this, I'm writing this particular code. So if fin1 dot end of file not equal to 0, okay, that means if this condition is true, we can exit from the file and hence terminate the program. Oh, sorry, in this case, because I'm writing exit 1, in this case, because I'm writing exit 1, it is just going to exit from this code block, okay, and it will move on to the next line if this condition is false. So again, just to explain at this point again, this for loop is going to run for 5 times. It can be anything actually instead of 5 over here. And every time I entered into this loop, I'm just checking whether end of file is reached or not. If it is not reached, it is going to read that line. Okay, it will be stored into your variable line. It is going to read 100 characters, and I'm going to print that line on the output device. Okay, so this is going to continue until end of file is reached. Okay, so if end of file is reached, to the compiler it will be printed that exit from file 1 is done. Okay, similarly, if you check the other lines, I'm doing the same operations on the second file as well. Okay, so as long as second file does not reach its end of file, it is going to perform this operation, and it is going to read line one by one, and it is going to print output on the output device. So this is end of your for loop over here. Okay, at the end of this for loop, I'm just closing these both the files. So what is exactly happening in this program? I'm going to perform a for loop for 5 times, that is starting from 1 to 5, that is 1 2 3 4 and 5, and it is going to read 5 lines from these two files. So here is the output of this program, because we are reading one line from the other one. So if you check here we are writing text from code.txt is the first line from the code.txt file. Then I'm writing text from kodegod.txt, and then the second line will be printed. And again, we are reading content from the first file, and this part will be printed. And the next is reading the next line from the second file. Okay, so what is happening that it is reading one line from these two files, one after the other one. Okay, so this is the output of this program. Important thing to understand here is that we can work on multiple files at the same time, but most important point is that we should remember to close those files at the end of the program or whenever your job is completed. As mentioned in, I think, first or second slide, a file can be opened in multiple modes. So iOS Team class has these multiple modes. So iOS :in is a read-only mode, wherein you can open the file in a read-only mode, but you cannot write content to that file. Second is the iOS : out mode, wherein you can open that file in the write mode only. And then there's app, that is append. So it appends content to the existing file. It won't erase anything that is already part of that file. So assuming, let's say you have 3 lines in the file, and whatever the content is being appended, it will be added from the 4th line. And then we have ate, that is go to end of the file on open. Okay, so whenever you have a file, let's say this, so this is, let's say, multiple characters. Okay, just to correct myself, so when you say app and let's say your file end is somewhere here, so the compiler will start appending your content from this particular location. Okay, similarly, when you say go to end of the file, so let's say you're writing somewhere here, so when you start writing from here, or you will start overwriting as well, like this. But when you say go to end of the file, so cursor position in the file will be somewhere here at the end. You can also open your file into the binary modes. I think this is something for the advanced users. So instead of opening into text mode, where text content will be stored, file can be opened in the binary mode, that is ones and zeros would be there. And there is another mode, no create. So this particular file opening function can fail if file does not exist in the scenarios wherein you don't want file to be freshly created if it already exists. So in that case, the file open function will be failed. Then there is no replace, fails if file already exists. So in case the file already exists and you want to ensure that I accidentally don't write content to the file, so you can use no replace mode over here. You can also write trunk mode, wherein you can delete content of the file if it exists. So these 3 modes are really useful when you have a mechanism wherein you are writing logs or you are writing some level of transactional information. So these kind of modes will be really useful. So just to briefly tell you how this mode can work. So to your output stream, you can specify these modes like this, and you can use pipe operator as well over here to specify multiple modes. We're not going to discuss this program in detail, but this is something I wanted to explain you in terms of how file modes can be utilized in your file open operation. But you can obviously try this program for understanding purpose. There are a few additional functions that I wanted to discuss, which are really useful when you have to handle few errors. So these are few error handling functions. EOF is important functions. It returns you non-zero value if end of file is reached, and it is really useful when you're reading certain set of characters or you're reading file completely line by line. So EOF is very important function and is very commonly used. You can use fail. It returns true when input output operation is failed. So this is particularly useful in case you're working on a very large file and you need to ensure that the contents are written properly into the file. So in case your input output operation fails in that case, so this function can be really useful. You can also use bad. It returns true when invalid operation is attempted to the file. So this could be cases wherein you are working on a restricted mode and the file is being used by some other process. You're just trying to perform some operation on a certain file. Obviously, these are functions that can be used by advanced programmers or users, but this is good to know. We know how these functions can be useful. Good returns true if no error occurred while performing certain operation, and clear, it resets error state to attempt further operation. So in case you're working on multiple files and let's say a write operation it's still in process, you have received a certain status of a file, you can use clear function which resets the error state and you can attempt the further operations on the same file. So here is one example how you can use error handling function. So I have written one very simple function. I'm using ifstream. I have created object fin of class ifstream, and then I'm using fin open, specifying the file name test.txt, and my mode is ios::in, which is, if you see here, it is read-only mode. Okay, so if this is read-only mode and we try to perform operation over it, it should fail. So I'm writing while not fin.fail, unless and until there is some problem with the file while performing certain operation, it is going to perform whatever the code is inside of this while loop. I am also writing if fin.eof. So if fin.eof is reached, so we can terminate the program. Else if fin.bad, and we are just going to return some fatal error is there. Else I'm writing fin.clear, that is clear error state flags related to the file. So this is some dummy code that I have written. It is not a standard example, because this is something that you can write depending on use cases related to your program. So this was just a dummy example. I hope I have made all the points clear over here. We are going to talk about how exceptions can be handled in C++ programming. So let us begin. Let us first start with the basics of what exception handling is and how it is managed or how it is written in terms of syntax in C++. So exceptions are basically, let's say you have a certain code wherein you are dividing two integers and the second integer is 0. In that case, compiler sometimes gives you error that a number cannot be divided by 0. But then along with the error, it will also terminate your program. So technically your program is not going to run 100% of the time. So to avoid situations like this, when you have certain care that you can take so that you can ensure that your program continues to run even if there is some wrong scenario that can get built up during the lifetime of your program. So this could be one case, but there could be another cases like you are working on files and the file does not exist, or maybe the file is not accessible, or anything. There are multiple cases and there are various scenarios wherein there could be errors, and we need to ensure that and these errors or exceptions need to be handled very carefully. So exception handling was technically not part of original C++ library. It was a new feature that was added into ANSI C++. The reason was when C++ got popularity, most of the programmers wanted this functionality to get built. So that is why there was huge demand for this particular feature. So that is the reason that this feature got introduced in ANSI C++. Exception handling mechanism is built around three keywords: try, catch, and throw. So these are three keywords: try, throw, and catch. So try basically detects an exception. So during your program, so let's say these are your statements. So this try keyword will ensure that it detects whatever the exception that can occur in the code block specified inside of these curly braces. And then you have throw, which throws exception when a problem is shown up by your code or that is detected by the try catch block. And finally we have catch block or the catch keyword. So if you just check this catch block over here, so whatever exception that is thrown by throw keyword, that will be captured over here, and then you can perform certain number of steps over here. Okay, so again, just to revise, try will detect error among these statements, and you can use throw keyword to throw the exception. And finally you can have a catch block wherein you can make use of the exception and execute certain statements. So we'll see one example on exception handling now. So this is one function division to which I'm passing two parameters a and b, both are integer. I'm just checking whether b is equal to 0,
and if it is equal to 0, I am throwing exception, specifying a string over here, that is division by 0 condition. And in case this is false, so this line will be executed, so compiler is going to return me a divided by b. So now inside of main function, I have two numbers a and b, both integer with initialized value as 10 and 0. Then I have another variable c of type double, and it is initialized to 0. Then now inside of try statement, I'm writing these statements. So this program is basically for to perform division operations. So let's say you pass 10 divided by 20, so there's no problem, you will get 0.5. But when you are going to perform 10 divided by 0, so there would be an error. So this exception or this certain condition we need to tackle, otherwise your program is going to get terminated. That would be an abrupt termination. So to avoid that, what I'm doing is I'm writing this code block inside of try, and I'm calling this function division, to which I'm passing a and b. So we have purposely specified values of a and b as 10 and 0, and I'm passing 10 and 0 over here. So division function will be called, so 10 and 0 will be passed over here. Because this condition is true now, b is equal to 0, so I'm throwing this exception now. Okay, so this string will be passed here as the character pointer. The character pointer variable is msg, that is message, and then I'm just printing this message over here on the output screen. So this code block will be executed inside of, which is in all the statements which are part of your catch block once the exception is thrown. So output of this program is this string, because obviously exception was thrown, it was caught by catch block, and this line got printed. So this is how beautifully we can manage exceptions. Now let us check how we can rethrow an exception. Okay, there could be certain instances when you throw an exception but you still require another exception to take care of. Okay, so assuming this is your main function, then cout, I'm just, for demonstration purpose, I'm just writing main function over here. So once the compiler reaches here, it will print on the output screen main function. Then inside of my try function, I'm calling this external function, that is exception handler. Okay, now if there is exception inside of this function, this catch block will be called. Okay, and this line will be printed. So now let us see what happens when this function is called. So inside of this function, I'm having another try block. So inside of this try block, I'm throwing exception, because this is an example, so I'm just throwing this exception directly. Now once this exception is thrown, so this catch block will be called, so this string will be passed over here to this character pointer, and I'm just printing cout exception in the function. Okay, and now when I call throw, so another exception will be thrown. So this is, we are rethrowing exception inside of a try catch block. Okay, so because this exception is thrown, this line will also be printed, because technically this whole function is part of this called function. Okay, so because exception is freshly thrown over here and there is no catch block attached to it, so it will be directed towards here. Okay, and this line will also be printed. Okay, so output of this program is main function, because this was printed first, and then from this function call we went to this particular function call, and then because this exception was thrown inside of this try catch, this catch block was executed and this line got printed, that is the second line, exception in function. And because of this throw, this catch block was executed, and finally this line was printed, that is exception in main. This is how we can rethrow an exception. Okay, now let us check how we can have multiple catch blocks inside a same function, inside a same program rather, I would say. So this is our exception handler function, this is our main function. So inside of main, I'm writing cout test multiple catch blocks, and then this is my exception handling function. This can be anything. I'm just passing two values. In the first line I'm passing 1, and in the second line I'm passing 0. So during the first call, let us see what is going to happen. I have passed 1 as a parameter, so a is equal to 1.
And inside of try, I'm just checking this condition whether a is greater than 0. If it is greater than 0, I am throwing variable a, which is nothing but a. Reason being a is greater than 0, so this condition is true and this exception will be thrown. Now because a is an integer, okay, so we have two catch blocks, one is here, another one is here. So this catch block has parameter as integer and another catch block has parameter as character. So because we are throwing one integer now, so this block will be executed. So it will print cout catch a integer and value of a, that is 1. Okay, and after that this function call will get completed, and then we have this second function call wherein I'm passing 0. So in the next iteration or in the next function call, when a is equal to 0, so this condition will be false. So this time this exception will be thrown, so throw character a. So now the second time this particular catch block will be executed, so it is going to print catch character and it will print a, that is 0. So based on what the type of exception that I'm throwing or whatever the information that I'm passing just next to this throw, a respective catch block will be called. So this is how multiple catch blocks can be utilized. So output of this program is this: in the first exception, because of this particular catch block, this output is printed, and in the second call, because of this particular catch block, this output is printed. So that was all, guys, for our C++ module. And with this particular video, we have completed our final module related to C++ programming. I really hope you like this video. I request you to share this video with all your friends on Facebook, WhatsApp. Do follow us on Instagram. We are uploading good amount of content there. Also do check out our website, that is kodegod.com, where we have uploaded all these programs. You can also download the PPT of C++ courseware. Not only C++, you can find other courses as well. You can also find programs that you can download for C++ and C. You can also download the PDF files related to both the courses. In case you have any suggestions or anything you want to discuss, you can use comment section below. Your inputs will be really valuable. Also comment out what would be the next course that you would want that we can build. I will see you in the next video. Till then, enjoy.